in a manner that will not be adversely affected by diversity, the safety and navigation at sea, and other marine activities. The permit or contract area shall be properly delineated by buoys marked with basic information, and no permanent structure shall be constructed. Upon issuance or renewal of the permit or contract, and before the start of the offshore mining operation, the permittee, contractor, or permit holder shall secure clearance from the Bureau which specify approximate area with ongoing offshore mining operations to ensure the safety of navigations. Prior to the use of any vessel or installations of any temporary structures for offshore mining operations, the permittee, contractor, or permit holder shall submit to the Bureau the name, basic description, and expected period of arrival or installations of the vessel or structure, and secure the appropriate permits or clearances from other agencies concerned, such as but not limited to Marina, PCG, and Philippine Port Authority. The permittee, contractor, or permit holder shall provide scheduled activity to the PCG or Philippine Coast Guard and the NAMRIA prior to its implementation in connection to their publications of the notice to mariners. Next is officials and duly authorized representative of the department, the DNR, or the Bureau, the MGB, or the MGB Regional Office shall have full access to structures, record, and vessels at any reasonable time to conduct inspection or investigation and or research work. Next is the permittee or contractor or permit holder shall have contingency plan for emergencies such as oil spill and fires and or disasters. Next is that the permittee, contractor, or permit holder shall notify the Bureau, copy furnish the regional office concerned in writing at least 30 days prior to the removal of any temporary structures, equipment, and apparatus within the permit or contract area. And next is that monitoring of the removal of temporary structures, equipment, and apparatus shall be performed either by the Bureau or by the regional MGB regional office concerned. With respect to the performance band, the permittee, contractor, or permit holder shall post to any government accredited bonding company or financial institution a performance bond in favor of the government in the amount equivalent to the highest annual expenditure obligations, provided the director or the secretary shall release the performance bond upon compliance with its financial, fiscal, environmental, and legal obligation, and provided further that if the permittee, contractor, or permit holder has failed to comply with this obligation, an amount of equivalent to its unfulfilled obligation shall be deducted from its bond, and provided furthermore that this amount will be used for mining operation in mineral reservations or to other purposes as may be determined by the Bureau, and provided finally that failure to pay the said amount within the prescribed period shall be a ground for cancellations of all approved mining tenements and denial of all mining applications. Some of the silent features with respect to explorations are the following. The permittee, contractor, permit holder shall comply with the Philippine Mineral Reporting Code or the PMRC in reporting of the exploration result, mineral resources, and or reserves. The report shall be accompanied by a raw geologic, geophysical, and geochemical data and shall be plotted in a 1:50,000 scale map at a minimum. It should state exploration strategies applied, supported by technical assessment based on the relevant geophysical, either seismic or bathymetry survey track lines, and geological sampling points, methods and analysis, and other information and data. Next on this is that the permittee or contractor or permit holder shall abide by the required annual area reading meant. The permit or contract area shall be platted over the sea bottom topographic or either bathymetry map generated from the survey at the scale of at least 1:50,000 as mentioned earlier. And another salient features in the exploration is that the permittee, the contractor, permit holder shall include in the exploration report any discovery of other offshore mineral resources. Another is that the permittee, contractor, and permit holder shall have the drilling platforms be enclosed with an oil spill containment boom, and only water-based drilling mud additive shall be used. Another guideline is that in the event of a discovery of a sunken treasure, artifacts, or shipwrecks, the permittee, contractor, or permit holder shall immediately cease operation within the discovery of the area and inform the National Museum of the Philippines and the Bureau within 24 hours from the discovery. The operation in the discovery area may only resume after securing the authorization or clearance from the National Museum of the Philippines. Some of the salient features with respect to the exploration of the parent vessels of the following: the conduct of offshore mining exploration in the exclusive economic zone, continental shelf, and the extended continental shelf shall be regulated and carried out by the state as provided by the UNCLOS. Any foreign ships, including marine scientific research and hydrographic survey ships, exercising the right of passage to the territorial waters, the EZZ, and the continental shelf used for international navigation or as archipelagic sea lane may not carry out any exploration activities without the prior authorizations of the states. And the request to conduct offshore mineral exploration within the exclusive economic zone, the continental shelves, including the extended continental shelf, unless otherwise agreed, shall be submitted through official or diplomatic channel not less than 6 months before the anticipated starting date of the project. And in addition to appropriate permit or clearances mentioned, the permittee, contract holder, or permit holder shall secure the permit or consent for the conduct of offshore mining exploration in the EZZ continental shelf and the extended continental shelf granted by the President upon the recommendations of the Department of Foreign Affairs. With respect to the salient features on the development and utilizations, the contractor shall utilize appropriate and efficient mining method with minimal adverse impacts on the marine environment. The use of high-pressure water jet in the extraction shall be prohibited. And extraction within a permit or contract area shall be systematically undertaken to minimize the extent of disturbance. It shall be clustered, confined with 2 predetermined meridional blocks at any given time. And systematic sequence of extraction shall be carried out in such a way that the non-valuable minerals produced from the onboard mineral processing shall be directed to and used as a backfill in the mine-out portion within the contract area. Next is that the clustering sequence of extraction and backfilling shall be incorporated in the 3-year development or utilization work program that's been submitted and approved by the Bureau. And next is that onboard mineral processing with the use of chemical shall not be allowed, while onboard testing, analysis without the use of chemical may be allowed. And the onboard size reduction processes shall be prohibited except when it is to be used for onboard testing or analysis. In cases where minerals or mineral products will be processed or reprocessed on shore, so this is speaking of on shores, a mineral processing permit shall be required, provided that the computation of excise tax and royalty to be paid shall be based on the gross market value of the final output produced from the mineral processing. And the right to the contractor to undertake the development, utilizations of offshore minerals does not include the right to lay out pipelines or other power lines and or installations of any structure outside of the contract area. Some of the silent features on the safety and health are number one, the permittee, contractor, or permit holder shall comply with the safety provisions of the implementing rules of regulations of RA 7942, or what we call the Dow 2010-21, and the mine safety and health standard, or known as the Dow number 2098, and other applicable rules and regulations. Also, the permittee, contractor, permit holder shall ensure that all personnel have the necessary experience, training, and qualifications, and conduct their duties safely and competently. And the permittee, contractor, and permit holder shall have at least one part-time safety engineer and one full-time safety inspector, provided that the safety engineer or inspector has undergone 100 hours of occupational safety and health training seminars, including basic training on safety of life of the sea and basic offshore safety induction and emergency training, and provided further that at least one of the safety engineer or safety inspector shall be on board the vessel and present at all times during the mining operations. Also, it is prohibited to employ any worker under the 18 years of age, and the permittee, contractor, and permit holder shall provide and maintain general alarm and public address system on the vessel or installation, and they should assess and address the hazard during potential interaction with other sea users, primarily fishermen and shipping companies, to prevent maritime accidents such as vessel collision and oil spill. And they should comply with the applicable safety and health rules and regulation imposed by Marina, PCG, by the PPA, Department of Labor and Employment, Department of Health, and other government agencies concerned. Some of the salient features with respect to environmental protections. One is that the permittee and contractor holder shall comply with the environmental provisions as been mentioned on section 166 of the implementing rules and regulations of RA 7942. And they should ensure the adherence of its mining operation to international standard as a measure of responsible mining in the country by securing an ISO 14001 certifications. And they should conduct progressive rehabilitation and other measures to control or reduce the impact of possible sea bottom topographic changes. They are also required to provide sediment control or containment, either screen or curtain, to minimize the spread of particulates. And they are required that the discharge of non-valuable minerals from onboard mineral processing using submerged pipes to ensure minimum dispersion of particulate. Also, on environmental protections, the permit holder, the permittee permit holder or the contractor shall immediately report to the regional MGB regional office concerned the Environmental Management Bureau and the PCG any spillages of fuel or oil and or other hazardous chemical substance with potential to cause marine pollution. And they shall ensure proper disposal of industrial, domestic, and nuclear waste, fuels, oils, and other hazardous chemical or substances in compliance with the applicable environmental laws, rules, and regulations. And they shall ensure the implementation of an appropriate closure plan, such as that the commissioned sites and associated ecosystem are rehabilitated and left in a safe and stable condition, taking into account beneficial uses of the site and surrounding seabed. And they shall ensure the safe and proper removal and disposal of any temporary structures in the contract area. And finally, they should conduct a coastal geohazard assessment in coordination with its Mine Environmental Protection and Enhancements Office or Environmental Office and the Bureau or Regional Office concerned, where the findings are to be communicated with the host and neighboring communities. Some of the features in the salient features on the social development, of this memorandum circular is that the permittee, contractor, permit holder, or its operator shall assist in the development of the host and neighboring communities in accordance with the provisions of Section 134 of the implementing rules and regulations of the RA 7942, and they should define the host community as the municipality where the mining operation is located. And finally, for the penal provisions, penalties and or fines shall be imposed for any violations of the provisions of this memorandum circular pursuant to Republic Act 7942 or its implementing rules and regulation, the DAO 2010-21, and the 2000-98 to the Mine Safety Standard, and other applicable laws, rules, and regulation, and terms and conditions of the permit or contract. Any violations of this memorandum shall constitute an offense punishable with a fine not exceeding 5,000 pesos. So this is the end of my presentation. Thank you very much for all sa inyo pong pakinig. Keep safe po, everyone.
So that was Sir Ted. Thank you so much po, Sir Ted, for that very informative talk on the guidelines on offshore mining. So once again, I would like to remind everyone, if you have questions, please put them in the Q&A portion of the Zoom window. You can also use the chat, but we implore you to please use the Q&A functionality. Your questions will be addressed at the end of or before the end of the program. There's a specific section for that. So let me just share my screen again. Okay, so we just had again Engineer Teodorico Sandoval. So let's move on to our next speaker. Okay, so our next speaker is Dr. Yolanda Aguilar. So she is the Chief of the Marine Geological Survey Division of the Mines and Geosciences Bureau of the DNR. She has received her bachelor's degree in the Mapua Institute of Technology. She took up her master's and PhD in geology at the University of Tsukuba in Japan, and her postdoctoral fellowship in the paleontology and museology at the National Science Museum of Japan. She has also been with the Mines and Geosciences Bureau for more than 3 decades and has contributed much to the development, research, policymaking on topics related to our georesources and georesources. So without further ado, let us have Dr. Yolanda Aguilar. Dr. Aguilar.
Good afternoon, everyone. Good afternoon. My topic is on offshore mineral resources of the Philippines. But before that, I would like to give you a short background on why we are conducting offshore mineral exploration. Uh, wait. I cannot share my screen.
Dr. Aguilar, do you want me to share your presentation po?
Ah, okay.
Yeah,
there
nag-start
it
na
is.
po.
It,
Nag-start na
Okay.
po. Yeah.
So this is my topic on offshore mineral resources of the Philippines. But before that, I'll give you a short background why we are doing this exploration. As we all know, the Philippines is endowed with rich mineral resources. From the northernmost part in the Luzon Central Cordilleras, we have gold, copper, iron, and manganese, and up to the southernmost part, which is located in Davao, we have this copper and gold mineralization. So, as you can see, the whole Philippines is covered with mineral deposits. So, the Philippines is a highly mineralized country. So it is considered the fifth most mineralized country with large reserves of gold and copper. It is among the richest gold mines in Southeast Asia. And in 1994, it has been estimated that we have 7 billion metric tons of metallic mineral reserves and 50 billion metric tons of non-metallic mineral reserves. We are known to be the most abundant, we have the most abundant chromite resource, considering Zambales as one of the largest chromite resource in the world. The Philippines ranks 6 for gold, nickel, copper, and chromite production, and has the potential to be the top 10 largest mining power in the world. So why do we have this mineral deposits? Because it has been reported that we are located in the western fringes of the Pacific Ring of Fire. So what is this Pacific Ring of Fire?
Hello, Dr. Aguilar. Can you use
Yes.
the presenter view po? Just click po the slideshow.
Slideshow. Okay. Sorry. I
Nasa
cannot
left po. Nasa ibaba po.
find.
Nasa bottom po of the PowerPoint.
Okay.
Yes. Oh, thank
Yes.
you.
Sorry. So we are located in the Pacific Ring of Fire. So this is the Pacific Plate, and this is the Philippine Sea Plate. And as you can see, we have lines of volcanoes around the boundaries of the Pacific, of the sea plates. And then along these boundaries, we also have the trenches. So this shows a lot of trenches. Trenches are actually cracks in the sea bottom that serves as avenues for mineralizing solution coming from the interior of the earth. So this is a cross-section of a trench. So the Pacific Plate, the old Pacific Plate, is subducting below the Philippine Sea Plate. And then parts of the subducting plate have been melted that contributes to the magma that comes out in volcanoes around the area. So if there are a series of volcanoes, we call it a volcanic arc. So this is the tectonic map of the Philippines. This is the Pacific, the Philippine Sea Plate. And then we have a trench here, the Philippine Trench. And we have the North Luzon Trough around here. We have the Manila Trench here from Batangas to Ilocos. And then we also have the Negros Trench, the Cotabato Trench here, and the Sulu Trench. Oh, well, this is the close-up of the trenches. And aside from the trenches, we have the so-called volcanic arc with mineralization of gold, copper, iron, lead, and zinc. And the violet parts are the ophiolite terrains. These terrains are actually composed of ultramafic rocks like peridotite, dunite that yield chromite, platinum, cobalt, nickel, copper, lead, zinc, and gold. So minerals are classified into metallic minerals and non-metallic minerals. So what did we have for metallic minerals? We have copper, iron, gold, chromite, nickel, and lead, and other minerals. And then for non-metallic, we have silica, dolomite, take note of dolomite. We have feldspar, phosphate, kaolin, limestone, etc. So going back to offshore marine mineral resources, they are classified as to minerals dissolved in seawater, surface minerals, and subsurface minerals. So these minerals dissolved in seawater are distributed on the continental shelf, on the continental slope, or in deep sea zones. Each cubic mile of seawater contains about 165 million tons of solids, making the 350 million cubic meters of water the world's largest continuous ore body. So the most abundant is sodium and chlorine in the form of dissolved salts. And by the way, since we're talking of minerals, water is also a mineral in the solid state. Surface minerals are those deposits found on the seafloor of the continental shelf, continental zone, and the deep sea zones. While the subsurface minerals are those found, of course, below the surface of the seafloors. And the best example for these subsurface minerals are oil and gas. So we will categorize the different mineral, the offshore mineral deposits. We have placer minerals, including gold, chromite, magnetite, silica. Actually, these placer minerals are accumulation of valuable minerals formed by gravity separation from a specific source rock during sedimentary processes. Actually, these are alluvial sand. And then under these offshore minerals are also aggregate resources, yung pong gravel and sand and gravel natin. And then we also have manganese nodules. Actually, these are deep marine mineral resources. We have ferromanganese crust, polymetallic sulfide deposits, and marine phosphorites. So under this ferromanganese crust, these are the cobalt-rich crust associated with copper, gold, zinc, and cobalt. Actually, they are formed on hard surfaces or hard seafloors without sediments. For polymetallic sulfide deposits, these are associated with chimneys or black smokers. While the phosphorites are known to concentrate rare earth elements and lithium during early diagenetic formation. So this is an example of the oil rig, and this is a ship conducting submarine mining. So this is a photo of a chimney or black smokers. And below is the dredging instrument of De Beers. I'm sure you are familiar with De Beers. It's famous for its diamond products. These are examples of offshore minerals. This is a fragment, a material containing gold, and this is diamond. This is an example of the manganese nodules. These are black sand or magnetite sand, and these are semi-precious stones from Madagascar. So this is how we see deep marine mineral deposits. These are actually black smokers, hydrothermal vents, and these are scattered manganese nodules. Manganese nodules are very abundant in the Clarion-Clipperton area between Hawaii and Mexico. So we're also expecting to find this kind of deposits in the deeper seas of the Philippines. Under marine mineral resources, we have the so-called volcanogenic massive sulfide ore deposits. They are usually composed of copper, zinc. These are associated with volcanic associated hydrothermal events in submarine environments. And this is an example also of a black smoker. By the way, we have found fossilized black smoker in Villa Malite associated with our asphalt deposit. So around this area in black smokers area, these are in very deep oceans. So that means Northwest Leyte was in a deep marine environment some 3 to 5 million years ago. And then since it's already dark in there, so there's no time for photosynthesis. So most of the organisms in this zone usually thrive on minerals and methane. So they eat methane. They're called chemosynthetic organisms. So why do we need minerals? We need minerals in our everyday life, from the cooking pans to the kitchen utensils, to the infrastructures, the cars, the transportation, airplanes, everything, and of course, the gadgets that we're using, computers and cell phones, and even paper, the production of paper and fabrics. We need minerals. So what is the status of deep sea mining? Actually, there is no existing mining operation in deep sea for deep sea minerals. Japan has completed its equipment testing offshore of Okinawa. And by the way, operations in deep marine areas are being monitored and governed by the International Seabed Authority. That refers to areas beyond the national jurisdiction of the Philippines. And then actually, ISA had permitted one mining company to operate in Papua New Guinea. And just like the Philippines, Cook Island is also revising regulations for manganese nodule mining. So the MGB, being the steward of the country's mineral resources, is committed to the promotion of sustainable mineral resources development. And from 2010 up to the present, we are in the process of revitalizing the mineral industry. The MGB has conducted National Geohazard Assessment and Mapping Program. And then we're also doing the rehabilitation of abandoned and inactive mines. And as reported by Engineer Sandoval, we are also reviewing the current mining policies. So these are the distribution of the different offshore minerals in the Philippines. We have cluster minerals including chromite, magnetite, and silica. We have manganese in near Palawan. And we also mine for aggregate resources. We also explore for decorative stones, offshore, and polymetallic sulfides. These are the distribution of the different marine mineral deposits in the Philippines. For gold, we can find this placer gold in the beaches and shallow marine areas of La Union, Lingayen Gulf in Pangasinan, in Aroroy and Momo, Masbate, in Paracale, Camarines Norte, in Rapu-Rapu Island, Albay. There are also gold deposits in the coastal areas of Marinduque, Inubaan Negros Occidental, Malimuno and Placer, Surigao del Norte, in Masaliped Island and Siana, Surigao. They also found gold in Panaon Island, Southern Leyte, in Masara and Tingting, Davao, and in South Cotabato. Magnetite sand is everywhere in the Philippines, from the beaches of northern Luzon and northwest Luzon, in Zambales, in Masbate, Bicol, eastern Samar, and southwestern Negros. As reported earlier, we have manganese near Palawan, onshore and offshore. For aggregates, we're looking for source of aggregates, sand and gravel for construction of government infrastructures in the Manila Bay, particularly the San Nicolas Shoal. Then we're also asked by PRA to assist them in the survey around Davao Gulf, in areas near Cebu and Leyte. We also would like to assist PRA in their survey in Biliran Island and also in Mindoro. For chromite, these are usually associated with ultramafic rocks. So they have it in Nara and central Palawan. They have coastal and offshore chromite in Masinloc, Zambales, Llorente, Hernani, and MacArthur in Samar, in Surigao, and Isabela. For silica sand, there has been reported occurrences in central Palawan, in Dumaran Island, Alimanguhan, San Vicente, Palawan, and in Rojas, Palawan. There's also been reported occurrences of palladium, platinum, and silver in Mindoro, Masbate, Panay, Negros, Tabla Strait, and the Visayan Sea. Muds from Imuruan Bay, San Vicente, Palawan, yielded silica oxide, potassium, uranium, zircon, and thorium. So this is the distribution map of iron deposits around the Philippines. So buong Pilipinas po, meron po tayong iron deposits. Kaya we're having black sand mining. And this is the distribution map of placer gold deposits. We have in northern Luzon. Probably this placer gold is coming from the central Cordillera, brought to rivers, the Bued River down to the coastal areas of La Union. Then we have Paracali district coming from Paracali gold mine. And then we also have placer gold in Masbate, in Surigao district, and in Davao. As I mentioned earlier, chromite or placer chromite are always associated with nickel. So, and ultramafic rocks. So these ultramafic rocks are found in the Zambales Range, in Isabela, in Eastern Samar, in Central Palawan, in Surigao District, and in the southernmost part of Davao. So how do we conduct offshore mineral exploration? The Marine Geological Survey Division, in the conduct of coastal marine mineral exploration, we do geophysical, geological, and oceanographic surveys. We do high-resolution seismic profiling, side scan sonar, and bathymetric measurements, piston coring, grab sampling of sediments and water samples, and sometimes drilling. But in this current project, we haven't done drilling yet. So this offshore surveys are usually simulated with data gathering done on board of the platforms that we use. And then even in the platforms, you already prepare the samples and do preliminary analysis. And then we submit the samples for laboratory processing and analysis. And from the results, we do the evaluation and then report writing. So what geophysical surveys do? We conduct a sea bottom topographic survey, seabed surface investigation, seismic investigation, and then piston core sampling, vibrocore sampling, grab and dredge sampling. So this is the old RPS Explorer, the survey vessel of the MGB. And if this RPS Explorer is not available, and for shallow marine survey, we usually use motor boat or small basnig as platform. So these are the equipments that we use. This is the sparker. This is the echo sounder for bathymetric survey. And for sampling, we use a grab sampler, the piston corer, and dredge sampler. Unfortunately, we lost one of our piston corer in the recent survey in Sulawesi. So this is how we do piston core sampling, grab sampling. And this is how we conduct survey using small motor boats. I think that's all, and thank you for your indulgence.
Thank you so much, Dr. Aguilar. That was very interesting. All of the things that you've talked about regarding the offshore mineral resources of the Philippines. So once again, thank you.
Thank you also.
Thank you po. Let us have our next speaker. So our next speaker is Engineer Ramon Santos. So I will just introduce our distinguished speaker. So he is both a mining engineer and geologist after receiving both bachelor degrees from the University of the Philippines. He also obtained a master's degree in mining and mineral technology from the Western Australian School of Mines, Curtin University of Technology at Kalgoorlie, Western Australia, and Master of Business Administration degree also from the University of the Philippines in Diliman. So, Sir Engineer Ramon has 39 years of experience in the mining industry. He has worked in the government, in the MGB, in the academy, in our department, UPD Triple ME from 1997 to 2004, and many companies in the private sector, mostly in the Philippines and in Indonesia, with limited work experiences in Australia, Malaysia, Japan, Papua New Guinea, and Solomon Islands. He is currently the CEO of the Solomon Islands Mining Company Limited and the Vice President for Operations of Mining and Project Development of MRMJ Earth Movers Corporation. So he will talk about the JDVC Magnetite Sand offshore mining project. Let us again welcome Engineer Ramon Santos. Sir Ramon?
Good afternoon. Thank you for that kind introduction. I'm sharing now my screen. I will share my screen first. Okay. Can you see it correctly?
Yes po.
Okay.
Though I think you need to full screen po yung presenter's view po.
Okay. Full screen. Teka, sandali ah. Sandali lang ah. Full screen. Okay na kanina pero ngayon. Pa rin. Can you see my screen or not yet?
Kita naman po sir,
Yeah.
though hindi po
Yan.
ata siya naka yung presenter's view sa PowerPoint.
That's sa PowerPoint. Okay. Okay, let me print screen. Okay, stop share ko muna. I'll try to share again.
Sige po. Try niyo po yung slideshow view po.
Teka, tingnan ko muna yan ha. How about that? Can you see that? No. Okay, I'll open it first before I share it to you. Okay, sandali lang ha. Hindi ko na ma-replicate yung kanina eh. Nasa successful sharing eh. Sorry.
Hello, Sir Mon. Sabi
Yeah.
po ni Doc Les, please select presenter view from among the options in the pop-up window after you click share screen.
Okay. Sige.
Yes po.
Stop share. Okay. Dito, anong pipiliin ko dito? Yung pop-up? No?
Presenter view, opo. Presenter view po. Select daw po the presenter view.
Presenter view. Teka, sandali ah. Full screen. Show manage participant, show chat. Dito eh. sorry. Okay, one last try and then if not, I will seek your help.
Sige po.
Okay, sandali lang ah.
Ayun po. Habang ginagawa po ito ni Sir Mon, I would just like to remind everyone, if you have your Q&A or if you have a question, please put them in the Q&A portion po of the Zoom screen, yung Q&A functionality. You can also try to chat po, pero as much as possible, we would like to have your questions in the Q&A functionality. Also, this program or this forum webinar is brought to you by the UP Department of Mining, Metallurgical and Materials Engineering and the Society of Metallurgical Engineers of the Philippines, or SMEP. Ayun lang.
I have a problem no, hindi ko na mabuksan siya. Yung nabuksan ko kanina, ayaw na mabuksan.
Sige, sir. Should I share na lang po?
Juan, can you... Ito na lang muna. Sayang kasi yung time.
Sige, sir. Ito po.
Okay. Is a full view nito, no? Is that a full view already?
Yes po, sir.
Okay. So, let me start my presentation. Actually, the timing of the presentation is just on the right order because our participants have been briefed on the policy of the Philippine government regarding the offshore mining, as well as the valuable information on the abundance of offshore mineral resources of the country, being an archipelagic. Now, my job this afternoon is to provide you an overview of a sample of a project. This could probably be the first offshore mining under the new guidelines that has been developed for offshore mining in the Philippines. Allow me to present the JDVC magnetite sand offshore mining project, and the order of my presentation so that you would know what to expect. Move to next slide, please. I'll give you a brief background so that you will gain an appreciation of what the project is all about the proponent, the location, the tenement history, significant project timelines that led to the current state of the project, the history of exploration, how we evaluated and estimated the mineral resource, and then the current project plans and operational parameters. And I will provide you with dredging or mining method, and some pictures of the vessels. And lastly, it will provide you also the simplified process flow sheet. Okay, next slide, please. For 2011. It is a mining company with a primary purpose of exploring, prospecting and operating mines and quarries of all kinds of ores and minerals. However, the primary business concern right now is the large-scale offshore mining of magnetite and other mineral resources, or particularly at this time is in the offshore of Cagayan province. The tenement in Cagayan is denominated as Mineral Production Sharing Agreement number 338 2010-2 OMR, amended A, covering 1,897 hectares in the offshore of Gonzaga, Cagayan province. The tenement is valid for 25 years and or until 2035 and subject to renewal for another 25 years. Next slide, please. Just to give you an appreciation or a picture of where the project's located, it is located in the offshore of Gonzaga, Cagayan, in the northernmost tip of Luzon Island. Based on my measurement using the facility of Google Map, you can see the distances of the nearest boundary to the nearest shorelines. So at least it is 15 kilometers apart. To give you an idea, for those who are not familiar with measuring distances, a Rizal Monument, which is the 0-kilometer point in the Philippines, and the oblation in UP Diliman, that is 12.4 in aerial or direct distance. So you can easily fit in here the distance between Rizal Monument and the oblation and still not reach the area. You are still short by 2 or 3 kilometers. About, around 3 kilometers. So that is how far the project site is from the nearest coast. Okay, next slide, please. Okay, to give you the project timelines, starting with the granting of the MPSA. The MPSA was originally granted in June 9, 2010. Originally, it is MPSA 338-2010-2 OMR without any amendments. And the original area coverage is 14,240 hectares. It was issued by the DNR to Bogo Resources Mining Corporation. And that is depicted in the picture as the strip of red line. The polygon that indicates the location of Sanchez Mira, Pamplona, Buluk, those are the offshore areas of these municipalities. So they are not the land area. So if you will notice, the southeastern portion, where there is a black boundary or polygon, is now the existing MPSA amended A. Through the years, the original MPSA has been subdivided or parcelized, and portions were issued to other mining companies in by virtue of or deed of assignment, and a portion was also relinquished back to the government. That's why the 40,240 original MPSA was reduced to 1,800. Okay, next slide, please. Okay. On November 25, 2011, after a year that the MPSA was granted to Bogo Resources, JDVC acquired the MPSA, the whole MPSA from Bogo Resources Mining Corporation through a deed of assignment. So it was officially transferred to JDVC. In May 16, 2016, 5 years after, almost 5 years, DNR MGB issued guidelines on the Philippine offshore mining, which is still currently being refined, reviewed, and revised. On May 20 of the same year, 2016, it is now possible to issue the ECC because of the guidelines. So JDVC obtained the previously applied ECC. It was granted in May 20. On August 15, 2016, the Sangguniang Bayan of Gonzaga issued another significant document, which is a certificate of no objection to JDVC project. Next slide, please. On March 26, 2019, the MVGB issued an evaluation report on the feasibility, issued the evaluation report on the feasibility study of the offshore mining project. On May 20, 2019, the MGB also approved the 3-year development utilization work program of JDVC. In July 29 of the same year, MGB issued the preliminary notice to proceed to conduct offshore mining operation. On August 7, 2019, MGB released the approval of the Declaration of Mining Project Feasibility. And on November 25, 2020, DNR Secretary finally approved the parcelization of the original 14,240 MPSA. Such the final holdings of JDVC has been reduced to 1,897 hectares. Okay, continue please. Now, let me give you the technical aspect on the history of the project. In 1969, probably the first documented offshore survey in the area was conducted by Anglo-Philippine Oil and Mining Corporation. And this study led to the discovery of magnetite sand deposits in the project areas. From 1971 to 1979, it was reported that MGB conducted mineral verification surveys in Chances Vira, Ballesteros, and Gonzaga municipalities. In 2010, through an exploration permit, the Bogo Resources Mineral Corporation conducted underwater sampling and random sampling of the beach deposits of magnetite sand. And after acquiring the property by JDVC in 2011, it started to conduct a more systematic exploration program consisting of geophysical magnetic anomaly mapping, seismic reflection profiling, bathymetric survey, diamond drilling, which is exactly similar or congruent to the practice of offshore exploration conducted by the Bureau of Mines. Next slide, please. Okay, just to give you a more detailed information, seismic reflection survey, the surveys involved 270 survey points along generally north-south, not exactly generally north-south traverses, which are 500 meters apart, more or less. And it is crossed by east-west traverses at 100 meters apart. So the diagram illustrates the path that the survey vessel undertook, the idealized traverse lines. Okay, next please. Okay, this is the result of the interpreted seismic profile lines. There are many of these, but I will just show you some of the profiles. The interpretation of the seismic reflection profiles indicated an interpretation of 5 units, consisting of Unit 1 and 2 on the near the surface, 3 and 4 intermediate depth, and then the acoustic basement. The acoustic basement doesn't necessarily mean basement rock, but it represents the abrupt change in the physical property of the material that would cause such boundary delineation. As you can see in the interpretation, the sediments or the units are consistent and continuous throughout the area. And this is one of the bases for the evaluation and estimation of the mineral resource. Okay, another profile line, please. Okay, this is another profile line in a different version. Sure, the sea bottom. Another profile line, please. That's that shows the consistent deposition of the deposits. Okay. By the way, Unit 2 and 3 are the most has the most potential to contain highest concentration of magnetite sand. Okay, continues, please. Okay, the bathymetric survey, in layman terms, it is intended to determine the configuration or topography of the seabed. It was conducted using dual frequency Teledyne EchoTrack MK3 high precision echo sounder set at frequencies 200 kilohertz and 33 kilohertz. The traverses consisted of 452 line kilometers with supplemental discrete measurement as control points or for checking verification. And the bathymetric controls and 3D rendering of the seabed were obtained using Surfer version 0.11 software. And the output is shown in the diagram below. So you can see the more or less the direction of the dipping and as well as the slope of the dip of the seabed. So the seabed is dipping towards the north, but to the east, the dip is becoming steeper. Next slide, please. Okay, for the drilling program, the company conducted drilling of 11 diamond drill holes ranging from 5 to 22 meters in depth from the seabed surface. And these are spaced between 2 to 3 kilometers apart. 6 of the deeper holes are located inside the final coverage of the MPSA Amended A. The other 5 holes are located just to the west. If in the diagram there is a portion to the west that are shaded by pink, so I just did not included that area because I would like to focus more on the final area of JDVC, which is this final area shaded by orange. So the 6 drill hole ranges in depth from around 15 to 22 meters. Yeah, 15 to 22 meters. And the analysis, the samples were analyzed based on the magnetic fraction, which is basically the magnetite portion of the deposit, of the sediments. Next slide, please. Okay, I would like to provide you an overview on how we evaluated the mineral resources. On August 15, 2015, after almost a year of study, CP report on the results of exploration and mineral resource estimation prepared by CP Rafael Liwanag was issued. And his study covered 4,999 hectares. That means the area that I shown to you, including portion of the MPSA area to the west. Evaluation was based on the recovery of the magnetic fraction, which would be the final product of the intended mining fund, which would be, yes, the basis for evaluating the mining project, the magnetic fraction. The specific gravity based on in situ measurements is assumed at 1.69. The conventional polygon method was used in the estimation of the mineral resource. CP Rapiliwanag did not use any cutoff grade in the resource, primarily because of the appreciation or consideration that selective mining is not applicable for this type of mining, dredging and mining method. Okay, next please. In July 2018, the MGB released its report on the evaluation of the report of CP Rapi-Liwanag using the same methodologies and assumptions, except that MGB applied a 5% magnetic fraction cutoff grade. So that means samples that has below 5% magnetic fraction were not included in the estimation. And also it applied a 90% recovery. The coverage rates remain the same, 4,999 hectares. In May 6, 2021, just this year, I was commissioned by JDVC to prepare a supplemental report to re-estimate the mineral resource found within the final mining area covered by MPSA Amended A 1,897 hectares. This is primarily in view of the desire of the company to implement absolute transparency. The previous reports of Rapi-Liwanag and the MGB covered 4,999 hectares. They were prepared in 2015 and 2018. However, in November 25, 2020, the DNR finally approved and registered in its record the participation of the MPSA, such that it's now official that the final holdings of JDVC is 1,897. The supplemental report is not intended to supersede the CP reports and the validation reports of MGB, but it is an independent evaluation and re-estimation of the mineral resource found only within this smaller area. So JDVC wants to be sure that the mineral, they know exactly the mineral content of the smaller area, which is the 1,897 hectares. Okay, the result of the 3 studies are provided in the lower part of the slides. CP Rapi-Liwanag in 2015 estimated that there are 359 million cubic meters of magnetite sand-bearing sediments with an average of 25.47 magnetic fraction. If we will convert that into tonnage using the 1.69 specific gravity, it's equivalent to 606 million metric tons. The MGB validation, I took the computation of the volume, which is 207 cubic meters, because they applied cutoff grade and also they did their own design of the polygon. They came up with 337 million cubic meters, equivalent to 569 million metric tons of magnetite sand-bearing deposit with an average grade of 26.50. This is understandable because the grade which are less than 5% magnetic fractions were deleted from the original data set used by 2021. My independent calculation using my own polygon design is 341 million cubic meters. I also adopted the 5% cutoff grade. However, I did not use any cutoff grade because this is only an estimation of mineral resource. That is equivalent to 576 million metric tons of magnetite-bearing sediments at an average grade of 26.27. So it's a little bit more conservative. But in terms of volume, it is all volume and tonnage. It is only 1%. 1% from in variation from MGB and 5% in variation from the CP report of Rapi-Liwanag. Next slide, please. The project plans and parameters. The MB ship on vessel 1 is already deployed in the mining area of Cagayan and undertaking extensive preparation that is required prior to the start of commercial operations, subject to test runs and weather condition. It has not yet undertaken any mining operation, and it has not sold or produced any magnetite concentrate yet. So, if there are magnetite deposits, it's not magnetite concentrate trades in the past. It is not from this project. It is from other operations governed by dredging permits. Okay, next, please. The overall general project plan sandali lang. The project target is 4,000 metric days of magnetic concentrate. Okay, magnetic concentrate is the concentrate of magnetite sand already. The target is to reach at least 60% iron because that is the marketable. Also, although 58% iron is already also marketable but subject to some penalties. Okay, the higher the grade of the percentage iron would be the higher the value in the world market of the magnetic concentrate. We plan to operate 20 operating days, 20 operating hours per day on the average or at 7 days per week to achieve 85% utilization rate. There will be some 15% of the time allotted for periodic maintenance. Due to the weather pattern over the northern coast of Luzon, the operating months is limited to February to September. The targeted annual production is 900,000 metric tons of magnetic concentrate. Continue, please. Okay, this is an idealized picture of what a seabed suction dredging. So this is not using based on the discussion of Engineer Sandoval, high pressure flow is not allowed. We are not doing high pressure flow here, but it is a suction dredging. So we clarify we use cutters to cut the seabed, especially the harder portion. And this is a picture of a dredger cutter and to facilitate the suction. So the picture shows the scale, how big is the suction cutter. Okay, continue on, please. Lastly, this is, I think, what is being weighted. This is the general flow sheet so far. This is still subject to modification and revision. But so far, this is the one that has been the result of feasibility study and met testing. The dredge material would be directed to drum screens, trommel screens, with a 10 mesh size screen, so that all the coarse materials bigger than 10 mesh would be placed back or returned to the sea, and only the minus 10 mesh would be accepted and directed to the wrapping magnetic separation. The process is using an old technology, which is magnetic separation, screening and magnetic separation, but the application is novel in the sense that this would be used in the Philippines for the first time for offshore mining. So the number shaded by blue represents the grade of iron. 100% represents the relative size of the material in terms of volume. So after roughing magnetics through the first magnetic separation drum with a magnetic strength of 21,000 Gauss, the non-magnetic portion, which is around 74 to 75%, would be released back to the environment. It is basically non-magnetic material with only 5% iron, which is within the background value. And then the remaining 26% of material, or 1/4 of the materials, would be that contains 52 or less than 60% iron, would still be processed for a second magnetic separation circuit. This time, it will use a lower flux, which is 1,350 Gauss, so that the mid links can be separated. And too bad the screen does not show the full slide. The magnetic product would be around 60% already. The non-magnetic is 36.29 as shown in this diagram. And it's about 1/4 of the material would be separated. Can take note that this 36.29% is higher than the original material, the REDS material. So this can still be subject to recovery, further recovery of the magnetic portion. The mid-links are the magnetite crystals that are still embedded in quartz and other non-metallic minerals. That's why it went, it joined the non-magnetic stream of the output of the magnetic separation cell. The final product now, after the second cleaning, the cleaning through the second magnetic separation circuit, would more or less attain the marketable value. Now, just to appreciate how this would look like in the vessel, I have several pictures. As I close this presentation, I'd like to show you the following pictures. Next slide, please. Okay, this be ship 1 vessel. Okay, next picture, please. Okay, you can see the drum. Angle. Next picture, please. Okay. Say top view. Next picture, please. Okay, pause for a while here. This picture shows the 12 circuits. No? Yes, yeah, that's better. 12 circuits. So the white drums are the screens, trommel mills. So the output of that would be the oversize would be returned to the sea as a non-magnetic portion, original material. And the drums are the magnetic separators. In each circuit, there will be 3 drums. So there are 12 sets of magnetic separation circuits. Okay, next, please. Thank you for listening. I hope I have given you, even if a little bit of information about the JDVC magnetite offshore offshore mining project. Thank you very much.
Thank you so much, Engineer Mon Santos. Now I will introduce the final speaker for today. Let me just share my screen. Okay, so Ayan. So we have Dr. Charina Lynn Amedo Repolo is currently the Assistant Professor and Co-Program Head of the Professional Masters in Tropical Marine Ecosystem Management in the Marine Science Institute, University of the Philippines, Diliman. So she graduated with a PhD in Physical Oceanography in the University of Hawaii, Master of Science in Marine Science uh, in the MSI or Marine Science Institute of UP Diliman, and Bachelor of Science in Fisheries in the UP Visayas. So her research interests include coastal and island circulation, high frequency radar remote sensing, air-sea interactions, mesoscale dynamics, and hydrodynamic and dispersal modeling. So she has conducted multiple research and has been part of several significant research projects with the Marine Science Institute on the study, development, and protection of our country's coasts and seas all around the Philippines. So let us hear her talk on the potential impacts of offshore mining on our oceans. Let's welcome again Dr. Charina Lynn Amedo Repolo. Dr. Charina.
Yeah, can you hear me?
Yes po.
Okay, good afternoon, everybody. And thank you for coming and to hear our talk for today. So I'm going to share my screen. Okay, and then I'm going to start. Can you see? Can you see the screen view of my slides? Hello?
Yes po, yes ma'am.
Yeah. So good afternoon, everybody, again. So I'm going to talk about the potential impacts of offshore mining to our ocean. So as you know from the previous presentation from JDVC, so the first offshore mining is in Cagayan right now. And regarding potential impacts, I have not, since this is the first offshore mining we have in the country, so I gather information regarding potential impacts from other countries and how they mitigate those impacts in our ocean. So before I discuss about the impacts, so let's go back first and explain some terminology and some terms regarding offshore mining. So let's define offshore and onshore just to differentiate these two regions in our ocean. So according to Republic Act number 7942, which is our Philippine Mining Act of 1995, offshore mining is defined as the water, sea bottom, and subsurface, which is the shore or coastline, reckoned from the mean low tide. So that's the delineation from the mean low tide level up to the 200 nautical miles, exposing economic zone of our country. So whereas the onshore region means the landward side from the mean tide elevation, so that's the keyword, mean tide elevation, including the submerged islands in lakes, rivers, and creeks. So now, if we overlay that definition into these various physical characteristics of our coastal zone, we can see here that the offshore, previously defined as from the mean low tide, so this is our mean low tide,
Hello, Dr. Charina.
until,
Hello,
yes,
sorry. We can't see po
uh-huh.
your presentation. We're only viewing the title.
Oh,
Yeah, yes po.
okay. Slide. How about this one? Can you see?
Yes po. What we can see now is the one with the Republic Act number 7942.
Okay, yeah, that's good. Yeah. So now. So I think yeah. So I'm on this slide. So I overlay here the definition on how the offshore and onshore regions was defined using our Republic Act number 7942. So these are the picture of various physical characteristics of our coastal zone. And based on that definition, offshore regions was defined as the regions from the mean low tide, as you can see here in the picture. This is our low tide shoreline, seaward until the 200 nautical miles exclusive economic zone of our country. And the onshore is from the mean tide landward. So in the offshore region, what you can see here is that it covers the area wherein underneath this is a typical sandy coastline. So wherein you can find a wave cut bench, which is a result of the waves, and then a longshore trough, which is a hollow region due to longshore currents and wave cut. And also there's a longshore bar, which is a result of the waves and the current, longshore currents flowing parallel from our coastline. And sometimes at this region, you can also see a storm bar or a sandbar because of the storm passing along this coastal area.
Yung slides mo stuck na naman.
So here is the global distribution of known marine mineral resources. So this is from the first global integrated.
Stuck yung slide mo.
Dr. Sharina, we're not seeing the next slides.
Yes.
We're not seeing po the next slides.
How about this one?
Hindi po. It's stuck with the one with the Republic Act.
Oh, there's a lag, I think.
It is stuck sa 757942 Republic.
How about that one?
Hindi pa po.
So naka-stuck pa rin.
I think you can just share the one that I gave you.
Sige po.
If that's okay. Okay, I'll stop share now. We are on slide 4.
Is this the slide po or is the next one?
Not the next one.
Ito po ba?
Next, please. The global distribution.
Here.
Okay, yeah. So this is the global distribution of known marine mineral resources around the world. So this was published by the United Nations and written by a group of experts, including our national scientist, as you can see, Dr. Angel Alcala, and the renowned botanist and biologist, Dr. Alonso. So what you can see here is that offshore mining from this report are currently confined to shallow water coastal regions. And as Dr. Yolanda mentioned also, there's no, as of 2016, there's no deep sea mining that is in operation right now. So all offshore mining are done near the shore of the shallow areas. And next slide, please. And here are the scale of offshore mining currently being operated. So the first one is the first type of offshore mining currently in operation, which is sand and gravel extraction. So they call it the aggregates, which is the currently the most mined minerals in the marine environment. So they are carried out at short distances from landing ports and at water depths of less than 50 meters. And they are an established industry in the Europe. And the top 5 are the Denmark, France, Germany, the Netherlands, and the United Kingdom of Britain, and Northern Ireland. The biggest one producer of sand and of these aggregates are the Netherlands. Next, I think, is the United Kingdom of Great Britain. This type of extraction is also in operation in tidal channels of the Yellow River in China, also in west coast of the Republic of Korea, also south of Singapore in between their islands, and in waters surrounding Hong Kong, China. So this is the sand and gravel extraction in the United Kingdom. So in the Northeast Atlantic, so as I mentioned, Netherlands is the largest producer, along with Denmark, France, Germany, and the United Kingdom. And this map here shows the coastline, showing the location of aggregates license areas in the United Kingdom and the adjacent coast of the continental Europe. Next slide, please. So another type of offshore mining is what they call the placer mining. So placer deposits include minerals that have been concentrated by physical processes such as waves, wind, and currents. So mining resources around the Philippines has been reported in detail and presented by Dr. Yolanda. So this one is just, an overview from the global perspective. And from here, you can see that in the Philippines, in Luzon, what only reported was the titanium-rich magnetite in the Luzon of the Philippines. And among this placer mining, the biggest one um, uh, in operation actually are the diamonds. That's global data from the global data. Next, please. So what are the potential impacts of offshore mining to our ocean, given that all of this offshore mining are conducted in a shallow waterbed and that it employed dredging system to excavate material from our seabed. So I will talk about, the process of mining uh, with different uh, mechanism or different methods. So here are the options on how seabed mining has been done. So these are different type of extraction permit and the allowable water depths that can be operated, and also the seaworthiness, which is a qualitative judgment on the ability of the technology to operate safely in a range of marine conditions, like if there's, waves, winds, and tides prevailing in the area. Production rate is a qualitative description of extraction that varies from uh, uh, 10 to 100 tons per day to 100 to 10,000 tons per day. And these are the limitations and the capability of this extraction technique. So far, this trailing suction hopper dredger has high seaworthiness and high production rate among the options that I presented. Next slide. So this is the process of seabed mining. So this is an overview on how seabed mining are being conducted. And it's good that JDVC also explain in detail on how their operation for offshore mining are being conducted. But just to have uh, a short discussion and overview on how offshore mining are being operated. I'll just show this to you now. So this diagram is from the CASIM. It's Kiwi against seabed mining in New Zealand. So it's a good and a simple illustration of how iron sand mining works. So here, it involves a suction pump that pulls the sand up from the seabed to a dredger ship above. The sand then will be sorted while still at sea. In the case of the iron sand, iron sand are get separated magnetically from the sand. The typical sand ore to ratio is about 90% sand and 10% iron ore. So JDVC can correct me if this is not the ratio that they're also that they are separating on how much sand and how much iron ore are they expected to get from those sorting or processing on board the ship. And then the valuable minerals or the ore will be transported out while the remaining materials will be dumped back to the water. Next. So given those operation, so this figure summarizes the environmental impacts associated with aggregate mining, which are potentially applicable also to all types of shallow water marine mining. So as you can see, there are direct and indirect consequences of marine mining or seabed mining. And one biggest direct impact or main direct impact that we can identify is the seabed removal. So seabed removal, the effect of that is that you alter or you change the bathymetry of the ocean. At the same time, you also alter the topography of the seafloor. And in that matter, because you remove the seabed, there's also an impact on whatever habitat or marine organisms you have on the seabed. And then another direct impact is uh, sediment plume. So one source of sediment plume is here in the dredging site and also during the sorting and processing of the sand and also during the uh, dumping back of the sand back to the ocean. So those are direct impacts. And those sands that can be uh, suspended in the water column will of course have a secondary effect. So it will increase turbidity. And the number two, change in tides and currents. This is a secondary or indirect impacts also because you alter the bathymetry, you alter the seafloor topography, so you will alter also tides and currents. And dispersal of the plume, so sediment will not only affect on the localized area where the dredging is happening, but this sediment can be carried away as a flume and will provide, turbidity on your water body. So another effect would be ship machinery noise. So ship machinery noise during dredging can, provide noise to our marine mammals or whales that can disrupt their communication. They can block their ability to look for prey and to get away from their and to also look for their food. So that's one of the impacts also that potential impacts from this activity. So next slide. So I just want to also to note that in addition to both direct and indirect impacts, there's also a cumulative impacts that can occur. So cumulative impacts are created as a result of combination of seabed mining project together with other activities causing related impacts. And they can be related to compounding activities in the single seabed mining operation, or if there's multiple mining operations also in the area interacting with each other. So these impacts also occur when there's an incremental impact of project combined with cumulative effect like climate change and effect of mining from past, present, and in the future project if there's mining that already existed in the area. So in this slide here shows the spatial and temporal scale of main effects arising from aggregate extraction activities and the confidence associated with the evidence. So given those potential impacts from seabed mining, so the group of experts summarize what are the spatial and the temporal effect of those activities. So for removal aggregates, impacts will be on benthic marine organisms and seabed morphology confined to footprint of extraction, the active dredge zone, and impacts would also include suppression of species, variety, population density, and biomass, as well as differences in species composition. So how long will this effect or how long in time will this effect can be observed? So once you have this effect on your organisms, so it says that recovery may begin after cessation of activity. And there's a good evidence for impacts on seabed habitats and biological assemblage published in this paper by Newell et al. In 2004. So another spatial scale of effect is impacts on cultural heritage and archaeology. So these impacts actually are very um, important if the mining areas has shipwrecks or if we have archaeological um, items or archaeological artifacts under the in our seabed. So whatever impacts we have on this cultural heritage and archaeology, it will be permanent and irreversible. So there's also a good evidence for that impact in this paper by Michelle et al. In 2004. And on the formation of sediment plumes, so from 300 to 500 meters of sand particles deposition up to 3 kilometers where particles are remobilized by local hydrodynamic conditions. So the temporal scale of that would be the longevity of sediment plumes would be up to 4 to 5 tidal excursion. 4 to 5 tidal excursion meaning you have 4 to 5 ebb and flood tide for fine particles. And this was documented in this paper. So confidence in understanding of sediment plume has been assessed as high according to the same report. On visual disturbance, it may affect seabirds and marine mammals. Special extent of effect depends on the organism. So it will depend from one organism to another. So it will be confined only to period of extraction activities. So, however, there's little evidence unlikely to be different from other forms of shipping or other forms of operation. So another extraction activities is the noise disturbance, the impact of that. So changes in noise levels detectable up to several kilometers. Behavioral responses likely to occur over much more limited distance and little risk of hearing damage. So this impact will be confined only to period of extraction activities. And evidence of that hearing thresholds only available for few species. So no other data has been presented for much more number of species, but only few species has been mentioned by CEPHAS in 2009. For the collision risk, so it will be confined to activity footprint, to this collision between ships in operation, and it will be confined to period of extraction and activities. And there's also little evidence unlikely to be different from other forms of shipping. For sediment deposition, from 300 to 500 meter for sand particle deposition, up to 3 kilometer where particles are remobilized by local hydrodynamic conditions. Heaviest particle settle almost immediately, while lightest particle will settle within one tidal excursion, meaning a tidal cycle of ebb and flood tide, according to CEPAS 2009. So confidence is high from modeling studies and direct observations at a number of sites. Next slide. So those spatial and temporal scale, however, depends on the type of dredging or the type of operation of the offshore mining. It will depend on the intensity of dredging, depending on the locations where dredgings are being conducted, and also will depend on the local hydrodynamic conditions of the location of offshore mining. So the report also gathered, these are documented environmental impacts of offshore mining for sand and gravel extraction. So here in Western Australia, in Owen, Anchorage, so this is from Walker et al. 2001. Dredging in shallow nearshore water associated with significant conservation values, example as seagrass, coral communities have adverse effect on marine habitats due to direct seabed disturbance and indirect effects such as elevated turbidity levels. Other concerns include changes in nearshore wave and current conditions, which could affect shipping movements and seabed shoreline stability. The seabed shoreline stability also promote a natural protection from storm surge. In the European Union, so the European Union includes 15 countries. So from OSPAR 2009, so this is actually an association or a committee of 15 European governments. So from that report, loss of abundance, species diversity, and biomass of the benthic community in the dredge area. So this is localized only on the dredge area, zone of the dredge area. Similar effects from turbidity and resuspension of sediment over a wide area. Benthic impact is a key concern where dredging activities may impinge on habitat or species classified as threatened or in decline. So another location and a documented impact was in France, in Pipi. So they have this 10-year monitoring program after the offshore mining. So, and it revealed a change in substrate from gravel and coarse sand to fine sand in the dredge area. The maximum impact on benthic macrofauna was a reduction of 80% in species richness and 90% in both abundance and biomass. In the surrounding area, the impact was almost as severe. So whatever the impact on the dredge area, it was also similar on the surrounding area. Following cessation of dredging, species richness was fully restored after 16 months, but densities and biomass were still 40% and 25% respectively, lower than in reference stations after 28 months. The community structure differed from the initial one, corresponding to the new type of sediment, because there's a change of sediment in the area from gravel and of course to sandy to fine sand. So next slide. So in the United States of America, actually currently there's no more offshore mining currently in operation in the US. But this was a review in 2013 by Michelle et al. Uh, in which she has a comprehensive review of impacts from dredging operation, identifying the most severe effect, which is entrainment of benthic organisms, destruction of essential habitat, increased in turbidity affecting sensitive fauna like corals and suspension feeding organisms. In Moreton Bay, Australia, impacts documented was alteration of the existing tidal delta morphology by removal of a small area of shallow banks. In most cases, the prevailing sediment transport processes would result in a gradual infill of the extraction site. And this is lastly from the Baltic Sea. Benthic recolonization at a site formed by sand extraction was investigated some 10 years after the cessation of the dredging. So this is a long-term monitoring of the area. And then after offshore mining ceased, they conducted this study. So the examined post-dredging pit is one of the 5 deep, which is up to 14 meters deep, that was created because of the dredging. So there's a 14-meter pit created with a static suction hopper on the sandy, flat, and shallow, like 1 to 2 meter part of the inner pack bay. So organic matter was found to accumulate in the pit, resulting in anaerobic conditions and hydrogen sulfide formation. Macrofauna was absent from the deepest part of the pit, and recolonization by pre-mining benthic fauna was considered likely. So there's no more chance that a benthic fauna will grow back to that area. So those are some of the documented reports of the impacts around the world that was compiled in that report by the United Nations. So I have to discuss here in the Northern Territory of Australia. So in Australia, they have a 3-year moratorium on exploration and mining in its coastal water. So it started in 2012 until 2050. And that moratorium was extended until 2021 just to ensure that appropriate review of seabed mining is completed. So my discussion in the following slide showing the impacts of shallow seabed mining is from this report by Smith in 2018. Um, this report is part of the 3 report that was prepared by the Department of Environment and Natural Resources to conduct a review of their seabed mining. So this report described the environmental values of the Northern Territories coast and seas. So they were able to identify what organisms and habitat will be affected, the potential impacts of seabed mining on the environmental values, and the information gaps to manage these impacts. Next slide. So they have an infographic showing the impacts of seabed mining on fauna or on organisms. So number 1, boat strikes and entanglement of wildlife impacting marine reptiles, marine mammals, fish, birds, and invertebrates. Because of the presence of equipment in the sea, so there's a tendency that there would be a boat strike. And also, if there's a light, especially during operation during the night, there can be also a bird strike wherein a bird will strike to the boat because of it will lose its orientation because of the presence of the light operating during the night. And then second one, identified impacts was underwater noise like blasting and vibration, potentially causing mortalities or stress, disruption of natural behavior, and reducing access to feeding grounds, nesting sites, and other essential areas impacting marine reptile, marine mammal, fish, and the invertebrates. So you can see here in number 2, uh, highly affected organisms are the turtles, um, the fish, and also the marine mammals. So another impact is chemical discharges and hydrocarbon spills, which can poison wildlife, impacting marine reptiles, marine mammals, fish, birds, and the invertebrates. And number 4, identified impacts was turbidity, which is the sediment that has been stirred up in the water column, coming from the sediment plume, and smothering with sediment impacting invertebrates and the fish. So sediment suspended in water column can also lessen the light penetration in the water column that can affect primary productivity. At the same time, it will clog also the gills of the fish and will have an impact also on that type of organisms. Marine pests, including foreign algae, shellfish, and other invertebrate species can compete or auto-compete and prey on native species of invertebrates. So this marine pest can be brought by equipment coming from other countries, from other or equipment coming from the other countries along with the ship that can introduce aquatic invasive species in the area. And then number six impact is the removal and alteration of habitat. So whatever, because you remove the seabed, in return, whatever habitat you have on that seabed will be altered and will be highly impacted. Next slide. So this one are the impacts of seabed mining on ecosystem processes. So our ocean have, various ecosystem services, and from that report in Australia, they just mentioned these few ecosystem services that will be affected by the offshore mining. So turbidity is one of that impact, which occurs when sediment becomes suspended in the water column, impacting primary production, as I said, because it will, reduce light because of the presence of the sediment in the water column. And it will impact also nutrient cycling and hydrology and currents of the ocean. And then organic enrichment can cause other significant disruptions to primary productivity and nutrient cycling in coastal communities. And next one is removal and alteration of habitat impacts will affect the food webs, primary productivity, hydrology, connectivity, and the climate regime. So another one is chemical discharges and hydrocarbon spills. Impact will be on primary productivity and nutrient cycling, so indicated by this gray circle here. Excessive sedimentation here, impacting primary productivity, usually primary productivity from the algae, and nutrient cycling and hydrology and oceanic currents. Underwater noise and blasting impacts the biological productivity. So those are the ecosystem processes that can be affected by those impacts due to the seabed mining. Next. So here are some of the mitigation measures now used with dredging operations. And here includes the use of silk curtains to contain dredge loops. So they use the curtains so that for those sand that will not be brought offshore, which is separated from the iron ore or from the valuable minerals, they will put it back to the sea, and they use this silk curtains to prevent the plumes from that sand that was putting back to the seafloor. And the next one is the return of the overflow waste to the seabed rather than in the water column. So they directly put the return flow back to the seabed and not on the mid depth or in the water column. And then another mitigation measure is to locate mining activities away from known migratory pathways and calving or feeding grounds of the organisms. Number four is limiting the number of vessels or operation in given areas. Number five is requiring reduced boat speed in areas likely to support marine mammals. So they have to lessen the speed of the boat not to interfere with those marine mammals passing along that area. Number six is engineering to reduce the noise of the primary recovery and or lift operations. And then number 7 is to limit unnecessary use of platform and vessel floodlights at night and ensuring that those that are required are directed approximately vertically onto work surfaces to avoid or mitigate seabird strike. So it should be focused vertically and not horizontally. So number 8 is leaving patches within a mining site unmined to increase the rate of recolonization and the recovery of benthic fauna. Number 9 is to exclude areas from mining if they support unique populations of marine life. Exclude areas of mining if they are potential sites of cultural heritage, and that depositing tailings within a small area as possible surrounding the mining block or onshore. And then lastly is to avoid the need for remining areas by mining target areas to completion during initial mining. So these are mitigation that they listed on that report on how to lessen the impact of dredging to our ocean. So next slide. So going back for the Philippines, so what you can see here is the map of the Philippines. So let's discuss what we have in the Philippines, what we need to protect, and what we need to consider for the offshore mining. So Philippines, as you can see, is an archipelagic country. It's made up of hundreds of islands. It has bigger total water area compared to the land area that we have. And our coastline is among the longest in the world, uh, with most of our coastal municipalities living around this coastal area. And that 60% of our total population live within these coastal communities. So in terms of oceanography, what we have so far in the Philippines. Next slide. Sorry, can you see my screen? Can you see my screen?
Ay, are you sharing your screen po? To?
Yes,
Sorry.
yes,
Okay.
I can see the screen.
Okay, good. So Philippines is situated uh, in a situated in the area where seasonal reversal of monsoons are prevailing. So what you can see in this picture is the 10-year mean wind pattern prevailing within and around the Philippines. So on your left is the wind pattern during northeast monsoon, and northeast monsoon in the Philippines occur from November to March. On the right is the southwest monsoon, and it prevails during May to September. So if you can see between these two seasons, there's a big contrast between the two. Northeast monsoon is more stronger and highly variable, whereas southwest monsoon is relatively variable and weaker in comparison to the northeast monsoon. And northeast monsoon, local term for that is amihan, while southwest monsoon, the local term is habagat. So using this wind, this red here that you can see on the left side of the Philippines are indicators of upwelling regions. And as you know, upwelling is a process in which deep, cold, nutrient-rich water rises towards the surface, and those upwelling areas or regions are considered to be biologically productive because of that mechanisms, and they are good fishing grounds. So those areas indicate upwelling, while the blue areas indicate the downwelling regions, which is the reverse of the upwelling. Next. Because of that wind pattern, it wind in the Philippines is the major driving force that generate our surface circulation. So because of that northeast and southwest monsoon prevailing in the area, we have this general view of our circulation around the Philippines. So on the Pacific side, we have this north equatorial current that doesn't changes over time. So it's similar direction, but only change in strength and magnitude. So that north equatorial current is the current that flows along the Pacific Ocean from the California side of the US going to the Philippines. And as it approaches the Philippine Islands, it separates into Purusho Current and then Mindanao Current to the south. That Purusho Current, part of that enters the Luzon Strait to the South China Sea and then into the Philippines. And on the west side, what we have is a big jar, a basin-wide jar, uh, rotating counterclockwise around the South China Sea, and also in the Sulu Sea, same direction, counterclockwise. And there's an going out circulation or surface circulation out from the internal seas of the Philippines from Panay Mindoro Strait out to the South China Sea. And there's also water moving outside to Sulawesi Sea along this archipelago in Sulu, from going out from Sulu Sea out to the Sulawesi Sea. In contrast, during southwest monsoon, as you can see, similar direction in the east side of the Philippines. However, in the west side of the Philippines, instead of the big basin scale circulation, we already have two dipole circulation, rotating counterclockwise in the north and then counterclockwise in the south. And that rotation also reverses during southwest monsoon in the Sulu Sea. So it becomes clockwise now, but similar going out from Sulu Sea to the Sulawesi. Next slide. So because of that circulation and the prevailing wind in the Philippines, this figure here shows the 16.5-year data of sea surface temperature and chlorophyll around the Philippines. So this monthly mean data from January to December, and as you remember, Philippines is under the influence or situated under the influence of the northeast and southwest monsoon. So what you can see in response to those prevailing wind and prevailing circulation around the Philippines is that during northeast monsoon, which is November, December, January, February, and March, Philippine waters are cooler, while we have higher chlorophyll A concentration during that time, which is November, December, January, February, and March. And in contrast, during southwest monsoon, our surface water are warmer and there's less productivity or less chlorophyll concentration uh, surrounding the Philippines. And what important to remember is those areas indicated in the wind pattern and the upwelling regions. So what you can see is upwelling regions are the indicator for that is that they have cold water and have high chlorophyll concentration. That's why you see here during northeast monsoon, wherein you have we had identified upwelling regions on the west side of the Philippines. Those areas are cooler, indicated by the blue color, and associated also with higher chlorophyll concentration here in the north of Luzon, here in between Mindoro and Palawan, Mindoro and Panay, here in Zamboanga, and some of the internal seas of the Philippines like Ticao, Visayan Sea, and also the Bohol Sea. And you can also observe between these figures that internal seas and the shallow areas here in Sulu Archipelago are consistently high in chlorophyll A concentration. So there's a very notable contrast between productivity and sea surface temperature characteristic or pattern within and around the Philippines during monsoon period, during northeast and southwest monsoon. Next. So what we have also in the Philippines are internal waves. So internal waves is another mechanism aside from the wind that drives upwelling. Internal wave also is another mechanism that increase or sustain a high productivity areas within and around the Philippines. And this figure here shows where can you find those internal waves. So here in Sulu Archipelago, so here at Pearl Bank, there's a internal wave generation that propagate from the Sulu Archipelago across the Sulu Sea up to Palawan. And there are also internal waves here in Bohol Sea or the Mindanao Sea, here in the Visayan Sea and north of Ticao, also here in San Bernardino Strait. These internal waves are generated by tides and it propagates and it's a big wave compared to the ordinary surface wave that you can see out in the beach if you're observing the waves, on the beach or outside in the sea. So these internal waves are gigantic and they are formed in the subsurface of the ocean. Next. And another internal waves we have is internal waves in between Luzon and Taiwan. So this internal wave between this area, we call this Luzon Strait, is the world's strongest internal wave ever observed around the world. So this has been an interest or a research study for scientific community. So a study by Alford et al. In 2015, published in Nature, revealed the existence of greater than 200 meters high breaking internal wave in the region of generation that give rise to turbulence level greater than 10,000 times that in the open ocean. So those waves have 200-meter high internal wave height. So can you imagine how big those waves are? But these waves, you cannot, they are gigantic, but they move slowly, and you cannot see it on the surface. Aside from the roughness, as surface expression of this internal wave. So it can be detected by satellite, and what you can see here are slicks as an indicator of the internal wave propagating from the Luzon Strait along this double ridge here in between Taiwan and Luzon, where these internal waves are generated and they're propagating to the South China Sea. And this one is the Dongsha Atoll or the Dongsha Islands of Taiwan, China. So here on the right is an animation. So it shows the color shows the temperature and indicating the propagation of internal wave from this generation side, propagating to the South China Sea and part of that to the Pacific side of this strait. So another important to consider is our marine biodiversity corridors. So as you can see here in the figure on the left, so marine biodiversity conservation corridors are indicated by the dotted lines. And those dotted lines are here. We also have here in Cebu to Passage Corridor. Also here, south of Zamboanga in Taptana Corridor. And also here, Pujosi Corridor. And also here, between Mindoro and Panay. And also here at Balapac Strait, south of Palawan. And also another consideration is the marine protected areas around the Philippines. So as of 2020, these are the marine protected area, locally managed, indicated by the green color, while the NIPAS sites are indicated by the blue color. So what we have here is the NIPAS site around Batanes. Also here in Palawi Island, Santa Ana, Cagayan. And here in Isabela, here in Sulusi, and some other locations. So you can see here the NIPAS and the locally managed MPAs. We have around the Philippines. So these are considerations that we can look to mitigate impact or potential impact of seabed mining to our marine resources or to our ocean. Next one. So this figure here just shows you uh, lots of benefits that we can have from our ocean. So with proper management and with a sustainable framework for our seabed mining, we can we can find a balance between conservation and between our economic benefit from our ocean. So this will be my last slide, and thank you very much for listening.
Thank you so much, Dr. Charina, for that very comprehensive talk on the potential impacts and mitigation techniques for offshore mining, as well as to our other distinguished speakers, to Engineer Ted, Engineer Mon, and Dr. Yoli. Um, I believe we have learned a lot and have effectively taken a look at offshore mining in the Philippines in a multifaceted manner. So now moving on, let us go to your questions. We will now proceed to the open forum. Please be reminded that some of the questions have already been answered by our panelists. If you will see, sorry, let me just, okay. So there, okay, so for the Q&A, I will call on one of our distinguished professors in the department. So she will be moderating this portion. We have Dr. Leslie Joy Diaz of our department, the UP Department of Mining, Metallurgical, and Materials Engineering, to help in moderating the Q&A forum for this portion. Doc Les, are you there po?
Yes, thank you, Ichan. So
Thank
can
you
you
po.
hear me ba?
Yes po.
All right, okay. So thank you again for the quick introduction. And we come to this part of our webinar wherein I think we need a lot of interaction between our speakers and our participants. So may I just ask our panel members to please answer the clarificatory questions that have been raised by our participants by directly typing your answers in the Q&A box or window so that we can focus on more, I should say, serious questions that were raised by our participants, and probably those that will still be raised following certain questions that will be discussed and answered during our verbal discourse. So maybe to allow for Dr. Charina to rest for a few minutes, now I will start our Q&A forum, our open forum, with a question for Engineer Ted. By asking, Engineer Ted already has answered a lot of questions in our Q&A box. And if I may just summarize some of them, Engineer Ted, many of your answers actually refer to the possibility or an ongoing efforts of MGBBA or DNR in amending or updating the RA 7942. Can you possibly elaborate more on that, Engineer Ted?
Yes, with respect to the fines, because it was stated in Republic Act 7942, the amount of 5,000 pesos in any other violations, and not on the IRR. So on that case, to be able to change the fine, we have to, of course, amend or propose an amendment to the Republic Act 7942, which of course entails our appeal to the Congress. So that is the reason why we stated that to be able to change the fines we need to, of course, amend the law itself. and it will take some time. So that is the reason why we cited that the needed amendment.
So further, siguro, sir, there's another question about any incentives that can be given to those who will follow the stipulations of our laws.
Yeah, it can be included actually on the proposed amendment. As I recall, there's an ongoing proposed amendment of the implementing rules and regulations of the 7942. But again, as I mentioned, it has to be studied well. No, there are some actually incentives that's been given, but with respect to these particular questions or suggestions, of course, it has to be studied well, because the situation in Indonesia is totally different with the Philippines. We have our own mining laws, rules, and regulations, and also with Indonesia. But giving incentive is, of course, it was included, no, on actually on a majority of our policy.
All right, thank you, sir. Sir, rest muna kayo. Lilipat muna ulit ako dun sa ating ibang panel members. If I may ask, Dr. Yolanda Aguilar, the question that I can see from our chat box is about, if I may just go back to it, no. Can you give us an idea on how much of our resources are still remains to be explored? No? What portion of unexplored offshore areas in the Philippines? Can you estimate more or less? No? Can you give us an estimation of that?
Good afternoon again. As far as the explored areas in the Philippines, I think we're just starting, because most of the researches that we have done in the past are merely exploration, or not in detail. So it's just part of some researches. So I think we are just in the process. We are still in the infant stage. So we still have to explore a lot of areas in the Philippines, because, as I've said, we have indications that these areas contains gold, copper, or zinc, but as to the amount or to the volume of ores that we have, we don't have a big data on this. We're still building our database.
Okay, thank you,
Thank you.
Dr. Yolanda. There is a follow-up, I think,
And
question from one of, yeah, you have.
if I may, I just want to ask to add to what Engineer Sandoval had answered about the incentive. Actually, the MGB and the mining industry are giving awards to different companies who are performing well in the exploitation of mineral resources in the Philippines. And that award is being granted every mining forum at the end of the year.
All right. Okay. Thank you, Dr. Yolanda. Then, if I may now proceed to Sermon. Sermon, one of the questions that are raised here asks for clarification why there was a need for the MPSA to be divided into portions.
That is purely the business strategy of the owner. If they want to sell portion of the MPSA, if they cannot mine the whole 14,000 and they think they can sell it to liquidate and get some cash that can be used for exploration, that's the strategy. So it's more of a business business scenario. So they sell portion to other companies, and one portion, more than 3,000 hectares, was returned to the government through relinquishment. So in the end, all of those are duly approved by the DNR. So in the records of the DNR, the parcelization has been in effect.
All right. So sir, ituloy na natin dun sa question ni Sir Eric kasi it's related to that as well yung technology, ano. So there's another question from Sir Eric that I think you already indicated you want to answer live. Please
Yes.
go ahead, Sir Mon.
Yung final product, ang target talaga is 60%. Based dun sa initial design, 2 pass. Una yung roughing and then scabbing, parang roughing and then refining to get 60%. Pero dahil ngayon nag-improve yung market ng magnetic concentrates, pag tumaas yung grade ng 61, 62, 63, malaki yung tinataas ng ng prices. So the company now is thinking of further refining the product. One is pelletizing onshore. So, pero separate na yan. No? Titignan mo para lang magkaroon ng value adding. So that's one. The other is yung middlings would be grinded. Mag-undergo ng one-stage grinding para ma-liberate yung magnetic materials. And this can also be separated separately in a separate so that is outside the original project. The original project, ang target muna is 60%. And the volume is 900,000 tons per year. That's the conservative estimate.
So Sir Mon, in relation to that, actually hindi ako sure kung nasagot mo na rin yung question about regrinding. To one of our participants asked, sa process flow sheet po, wala po bang regrind operation na pwede i-consider?
Wala. There was an independent study, I think involving MIRDC and DOST. Yun nga, regrinding would increase the recovery and grade of the final. Kaya lang, siguro tingin ko rin, instead na ilalagay yung regrinding at the initial stage after screening, where you regrind substantial amount of material, i-regrind mo na lang, yun na lang middlings. So, hindi pa established kung saan ilalagay, but regrinding is an option to increase the grade. So that is still not considered.
So that will require a different permit, sir, for the MPSA
Yes.
onshore.
It could be a different project per se kasi yung ang mahirap kasi sa vessel, limited yung space . At saka pag na-design na yung vessel from the beginning, mahirap ng reticulate or i-redesign. So siguro yung na lang, titignan na lang how we could further improve yung products. It could be, kasi ang problema yung as I reported, 7.5 months lang per year ang operation offshore because of yung waves and yung upswelling ng water. So kung yung mga middlings or even the concentrate would be processed onshore, it can be operated 12 months a year. 24 hours a day. 24 hours a day, sir. Pwedeng 7/24. So it would be a different project na pag nagkakaroon. Although it could be the same proponent, but a downstream project.
Thank you for that, Sir Mon. Sir, pupunta ako sa medyo mahirap-hirap na question sa tingin ko. Meron tayong tanong from Aaron Nieveras. But hindi ko na babasahin yung kabuuan ng kanyang tanong. I'd like to now just get the gist of his question. He's asking about the mint of course, I think I would now believe that this is really directed to you, sir, being part of JDVC. The commitment to meet environment and community expectations.
Yeah.
Can you share with us any efforts of the company that you're doing in relation to what Dr. Charina has also mentioned earlier, yung mga impact to environment, and then there are measures that she shared also that you might also can share if you're doing it already or it's part of your plans. Sir?
Yeah, first of all, the answer there is we've been granted ECC. And the ECC is subjected to extensive EIA study and evaluation by group of experts, the REPCOM. So that's one, no? So there's a vouch by the Philippine government. And among the, to be more specific, yung mga yung pinaka-major impact naman ito yung plumes eh. Kasi dun sa seabed, na rich in magnetite, unlike in other areas like aggregates ang miminahin mo, siyempre coral reef, may coral reefs yun, yung mga aggregates. Talagang iba yung impact. Pero doon sa seabed na maraming magnetites, walang corals, wala kami nakitang kwento yung place na where the organism will yung ecosystem niya is very simple. Highly disturbed na nga siya eh. Kasi depositional site siya eh. Natatabunan siya palagi ng sand derived from the river system. So yung ecosystem itself, it was extensively studied and hindi siya similar with what other things na may coral system, may maraming isda. May isda rin pero hindi yung it's not like a coral reef, no. So yung plume na potential impact niyan, pinag-aralan namin curtains. So may mga design ng curtains to minimize the plume. At saka yung recommendation na pag nag-return ng sand, hindi ibabagsak sa dagat yon. Idadaan pa rin sa pipeline yon. So that yung plumes would be avoided or prevented. So yung mga ganun meron yan. And the company is ISO 14,000 certified, 9,000 and 14,000 certified. So all the system has been verified, audited, and evaluated. In terms of social, during the exploration stage, may mga social projects na. One specific I know is yung computer school on wheels. So may computer school on wheels even before the pandemic. Ginagawa na yun ng JDVC. So pinapaikot nila yung bus na to train people on computer, the use of computer. Parang maging computer literate naman yung mga tao sa remote areas. So that is one that I know. There are many others that I'm not aware of because I'm only an external consultant to the company. I'm not really part of the warm body of the company. Technically, I'm only involved in the mineral resource evaluation. So yun ang konting medyo mahaba-habang sagot.
Okay, thank you so much, Sir Mon. Sir Mon, pupunta muna ako kay Doc Charina para makapagpahinga naman kayo konti. So the question here that I'd like to be raised to Doc Charina is that there is a question from an anonymous attendee, but the question is, how far should the mining operations be from a habitat of unique marine population, if there is any, to avoid possible impacts?
Yeah, the distance would be depend on the intensity of the seabed mining that is ongoing. So we need to further study that because from my research, there's one documented study that impacted the habitat in the dredging zone and also on the surrounding area, but they did not indicate specifically how far those surrounding areas are. And it will differ from one location to location because we have different hydrodynamic conditions. We have different, physical environment in each place. So in order for you to see how far the impact will affect the habitat will really depend on the research that you have to conduct in that specific area. I hope
All right.
I answered the question.
Okay. This one I think is also related to that question. Ano, it's a similar question, but it's a different location, na, no? Or specific location. Can you possibly share or have an idea of how will proposed mining projects in Cagayan affect the NIPAS and some KBAs in the region? I'm not so sure what, sorry, hindi ako familiar kung ano ang NIPAS at KBAs, ano? But
Yeah.
anyone from the group might be able to share what NIPAS and KBAs are.
Yung map na na-share si Doc. Si Doc.
Yeah. Oo, yung
Is it-
NIPAS are National Integrated Protected Areas, you know.
All right. Sige pa.
Yung difference lang yan kasi 'di ba meron tayong locally managed na mga MPAs managed by the LGUs or the communities or the organization. And the NIPAS are managed by our national government. So in Cagayan, we have Palawi Seascape, NIPAS area yon, and then also in Batanes. So if there's a hydrodynamic modeling that was conducted in Cagayan, we can see how far sediment plume, can be how far the sediment plume can reach these coastal areas, at kung saan areas will be impacted by the plume. So if JDVC has hydrodynamic modeling, we can show that na hindi aabot doon or aabot ba siya. So we can mitigate o kung anong measures ang pwedeng gawin to prevent yung impacts doon sa ating mga MPAs.
So that means, ma'am, no, it's an area of research pa na kailangan.
Kailangan nating matingnan. Yeah.
Yeah, DNR or the OST can fund this kind of project, no?
Mm-hmm.
I think it will be useful to show the map again. May maganda yung map na pinakita ni Dr. Shereen.
Oo, you can share it on your end kasi di ba nagka-problem ako.
Doon sa moderator natin, or moderator sa natin.
Host
Okay.
natin.
Can you possibly share that map ulit yan?
Yung
Hindi sa akin.
natin,
Sa presentation niya.
sa presentation
Kay
ko.
Doc Charina po.
Okay siya.
Hi, Doc.
Yan, the 25.
Sige, up taas pa.
No. Down. 25 na ano? So
Slide
25.
25.
Slide 25, yes.
Ah,
Slide 25. Yeah. 25. Yeah. So
Yan.
ito yung ating mga marine protected areas. So I think the nearest one is the Palawi NIPAS site. Yung andito sa tip ng Cagayan. Santa Ana, Cagayan. Yan. Yung maliit, halos hindi mo siya makita dito sa tip ng yan. That's the Palawi NIPAS site. So Palawi Island, protected landscape and seascape. So we can use hydrodynamic modeling actually to identify kung aabot ba ang sediment plume dyan sa area na yan.
Our project site is southwest of that. So it's more of a downstream of the, what do you call that? Crucio
current
current, yeah.
that entering the Babuyan Channel, sir.
It's going northward, di ba? Northwestward.
Yeah, in Babuyan Channel na area, yung kanyang main path.
So we are on
Sir, meron ba kayong hydrodynamic modeling?
Meron sila.
Ginawa?
Yes, meron.
So yun pwede nating tingnan just to show.
Doc Charina, if I may push that further, no? Can you share with us how long that study is going to be implemented in case that will be pursued, for example, by the company?
Hydrodynamic modeling actually, usually we do it like 3 to 6 months, as long as the data are already there. So important for the hydrodynamic modeling is the bathymetry of the area. So yun yung pinaka-importante, yung bathymetry, and also data like temperature and salinity, and also we have tide gauges in Cagayan that we can use as input for the model also, and there's also wave gauge binambria also in Claveria that you can use as input for hydrodynamic modeling. So we need baseline data as input for the hydrodynamic modeling, and as long as those data are available, we can do it at 3 to 6 months.
All
Pero
right.
kung kailangan pang mag-gather ng data, then more time will be needed to do that.
All right, sige. May nag-raise hand daw. Let me just check who this raised hand is. Whose hand is this that is raised? Teka, titingnan ko lang po muna. Mr. Richard Alamo. Yes, can you please provide audio for Mr. Richard Alamo?
Ma'am, sorry po, na-wrong click lang po ako. Sorry po.
All right. All right, okay. Teka, may... Okay, so si Engineer Ted, ano, he's asking if he can leave daw sometime around 4:10. So siguro may mga ilang questions tayo bago lang umalis si Engineer Ted related to policies. Sir, yung isa sa mga nakikita ko ngayon sa ating Q&A box is about legality of parcelization ng area under one corporation. So I think this is in relation to that yung pag-partial from the 14,000 to naging 1,008. Tapos ito ngayon yung napunta kay JDVC. So I think that's the one that this is referring to. Can you provide some enlightenment in that aspect, sir?
Yes, actually po with respect to MPSA, when it was applied, it cannot be divided. Ang nadi-divide po kasi yung magkakaroon ka ng ng contractor or subcontractor or contractor on that, no. But recently meron kaming ginagawang policy na dapat isang MPSA, isang contractor. Kasi po ang nangyayari nga, meron minsan na isang MPSA naghahati-hati yung mga contractor. So ina-apply po ang NPSA, it cannot be separated, no. So pagka nag-apply ka, it should be one NPSA, and then you will apply for another area, it should be another NPSA. So ang nahati po siya nga ay kapag may mga contractor na, bale, no? So there can be, previously po mayroong mga more than one contractor in the NPSA, kaya naghahati-hati sila, no? But NPSA itself is hindi po siya pwedeng mahati. So but again, sabi ko nga po, meron kaming draft guidelines na dahil nga para ma-address yung ganung problema sa mga conflict in the contractor and MPSA holder na na dapat isang MPSA, isang contractor lamang po.
All right, I hope that
Clarify that kasi I'm involved in that. There's a misinterpretation na hinati yung MPSA to magkakaroon yung kunyari naging 4 yung MPSA. No, in relation to the comment of Engineer Sandoval, isang MPSA lang talaga yon. And like his comment, in accordance with his comment, nagkaroon lang ng contractor in different areas. Kaya nga yung contractor naman, ang either deed of assignment or operating agreement, which is purely legal. What is illegal is yung isang MPSA mo, lalakihan mo ng lalakihan, mag-extend ka na mag-extend.
Correct.
Yun ang problema. Pero yung sa government, ini-encourage nga natin yung relinquishment eh. Di ba? So what is illegal when the MPSA is reduced? I don't see any illegal aspect. Kasi nire-reduce po pa nga eh. Kung baga sa yung potential area that would be potentially disturbed through mining will be reduced through relinquishment. So it should be welcome guy na lumiliit yung MPSA area. And the MPSA area number is the same. Nagkaroon lang ng amended A, amended B, amended C. So there's nothing wrong. It's all within the mining law.
Okay, thank you for the clarification, Engineer Ted, Sir Mon. Another question that I think is of interesting perspective dito sa ating laws in the governing mining may tanong dito, it's from an anonymous attendee who is asking, isn't it that the hydrodynamic modeling required or part of the EIA? Preparation for the project, no? So I think this is in relation to the EIA, the ECC, no? So siguro yung I guess, elaboration that's needed, and more of siguro a good description of how ECC is obtained, to cover more or less no the cover and know how the companies are preparing for the potential impact to, or addressing the potential impact to environment, no, and communities. So I think Sir Mon, really, Sir Ted, related pa rin po ito sa inyong scope ng presentation. Pwede nyo pa kaya sagutin?
Actually, pagdating po sa environmental, no, it is always sa EIS, ano po yan, Environmental Management Bureau nag-handle sa kanila, no? Ang ina-handle po nila ito actually. So sa MGB po yung what we are up.
Hala, ako ba nawala o si Sir Ted?
Si Ted.
Ayun. Hindi ako sure,
Yeah.
Sir Mon or engineer.
Yeah.
Ayan na, Sir Ted, we lost you a bit.
Okay, as I repeat, medyo po naging unstable yung ano nga dito, no, yung internet connection. Okay na po ba? Narinig niyo na ako?
Okay.
Or...
Yes, sir.
Yun
Yes,
po,
sir.
as I mentioned, it is more of the concern of the Environmental Management Bureau kasi po incorporated to those submissions sa EIS. Sa MGB po kasi, it is not included actually, except kung hihingin ng MGB yung data patungkol nga doon sa hydrodynamic modeling. But in the MGB side, what the company submitted to us and we review and approve is yung pong environmental protection and yung environmental protection and and enhanced program, no, yung EPEP. So more on EMB po siya concerned sa EIS.
If I can provide also an answer.
Yes, go ahead, Sir Mon.
Based on my experience as a former member ng EIA Review Committee, part of my profession is environmental consulting. Yung mga projects that would apply for ECC, magsasabit muna sila ng intent and then project description. And the EMB will organize a special team na tinatawag nating review committee. It is an ad hoc in the sense that this is created based on the expertise mix ng group that would match your requirement ng project. And the members of that are high caliber personalities, not only from the government, but from the academe and from the private sector. Like the caliber of Dr. Sharina Repolio. Ganun yung mga members niya, very distinguished. And one of the first steps na gagawin ng EIA, yung scoping session. The scoping will define what are the potential impact, extent of impact, and therefore the studies that will be required. So the EIA system is fully functional and efficient in ensuring those important environmental aspects will be considered. So let's be confident with the EIA system.
All right, thank you for that, Sir Mon. No? So actually, dudugtong siguro ako dun sa sagot nyo na, Sir, no? And then I'll throw this question to Dr. Charina. Dr. Charina, the mitigating technologies or techniques that you have shared with us, as well as the potential areas of concern regarding the impacts of these offshore mining, no, and related near-shore deep sea mining activities, do you think it has been covered already, if you're familiar, by the ECC and the EIA coverage or stipulation, or you think there's a good room for opportunities of doing a lot of research given the uniqueness that we have in the country, in order to ensure that we are able to manage well this need for development, as well as protecting our biodiversity and so on and so forth, the marine ecosystem. So yun po.
Yeah, so actually, the EIS guidelines of our government, already had an overview what necessary data and what necessary tools we are going to use to manage and mitigate, adverse impacts to to offshore mining. But some impacts are site specific. So we really need, so along with those guidelines, we really need to have like a localized research in each area kung saan ilalagay yung isang operation for mining. So I think for every mining located somewhere in the Philippines, we need a localized study that we need to do. Ano ba yung existing habitats doon? Ano bang valuable organisms yung nandun? And then do a hydrodynamic modeling to see the extent of the impact of from the operation and what organisms are mainly affected by it. And it's localized, so it's different from one place to another. So I think that's the thing that we have to do. Though we have the set of guidelines, general applicable for the whole Philippines, but we need more research on a site-specific areas.
Okay, thank you for that, Doc Sharina. No, so parang now really is that requirement, no, to understand the local areas where these mining operations will be performed, no, para mas customized, kumbaga, yung ating measures, okay, in order to mitigate impact.
Another thing pala, kasi tiningnan ko din yung guidelines for EIS. There are yung hydrodynamic modeling kasi is not specifically detail yung ano bang dapat hydrodynamic modeling yung ginagawa for offshore mining. Kasi iba siya for ibang hydrodynamic modeling like yung mga mining natin from the land that need an expansion near the shore. Iba kasi yung ano niya ang requirement niya for hydrodynamic kaysa doon sa offshore. Sa offshore mas complicated na kasi nasa water column na yung suspended na sediment. So ibang approach. So I think yun yung nakita kong kailangang i-refine siguro for offshore mining is on how hydrodynamic should be conducted. Kasi hindi siya nakadetalye doon sa EIS. So hindi nakaka-capture ang dapat sanang makita para ma-define talaga natin yung impact using the hydrodynamic modeling. So there are specifications on what should be in the hydrodynamic modeling na kailangan for offshore mining. Specifically for offshore mining.
Oh, all right. Okay.
Yeah.
Sige. So I think that opens an opportunity for research, a collaboration between JDVC and your research group, Dr. Rina, kasi nga it requires some further development pa in terms of determining the hydrodynamic contribution to impact, to mitigating impact.
Yeah.
No. So moving forward po, you indicated here that you want to answer live with a question from an anonymous attendee. May pagkakaiba po ba ang nearshore or offshore mining? Ano po ba batay sa ating mga batas? And the definitions of no offshore. Please go ahead, Dr. Rina.
Yes, based kasi doon sa Republic Act number 7942 natin or Philippine Mining Act. Ang dinefine lang doon is offshore tsaka onshore. So, dalawang definition lang. And if I overlaid the offshore and onshore definition from that act doon sa physical characteristic ng ating coastal area. So, yung offshore actually include the nearshore. Kasi magkaiba yung definition eh. So, scientifically, in physical oceanography, ganun yung definition namin ng nearshore and offshore. Pero yung ating Republic Act, iba siya. Iba yung kanyang demarcation line to define the offshore. So, ang offshore and onshore lang yung klarong define doon sa ating Mining Act. So, yung offshore is yun nga, from the mean low tide hanggang 200 nautical miles sa exclusive economic zone natin. So, kung titingnan mo, ang mean low tide na yon, so, sakop niya talaga yung malapit sa shore natin. But of course, it will vary from one place to place kasi yung tide level naman natin around the country is nagbabago din from one place to another. So very dynamic yung area na yun. So magbabago talaga siya from one place to another.
Related to this question, to what you're answering, siguro, Dr. Rina, is offshore mining and seabed quarrying the same? I don't know if you can answer this, or Sir Mon siguro, no? If not, what are their differences? Thank you.
Doc Les, ano ngayon? Kindly repeat that. Doc Les.
Sir Mon, naka-mute po kayo.
Ayan, hindi na ako naka-mute. Naka-mute pa ba?
Is offshore mining Okay na.
Okay. Pakiulit lang yung question.
Medyo is offshore mining and seabed quarrying? If not, what are their differences?
Offshore mine, yung quarrying kasi pertains to pag sinabi mong quarry, it pertains to non-metallic and industrial minerals. Like for example, yung San Nicolas Shoal would na mentioned in one of the presentation is a potential source of aggregates. That is the offshore quarrying. Pero yung offshore mining is a general term that can be applied to both. Mas specialized yung quarrying. Yung mining can be used for metallic like magnetite, titanium, rare earth, and also non-metallic like phosphate rocks, and manganese is metallic, no? Hindi kasi ako expert dyan sa chemistry. 4 lang ako dyan eh.
Alright.
Basta sa offshore, it can cover both metallic and non-metallic. Pero yung quarrying, based on the usage na among professionals, it pertains to industrial materials. Actually, not really materials.
Okay. Sir Mon, a question here has been raised by Joey Aison.
Yes.
How deep is the water in the proposed dredging operations, and how many meters below the current seafloor will the dredging extend?
Yes. The MPSA area has a depth of around between 30 to 60. More or less 30 to 60 yung water depth. And then below the seabed, ang maximum na based sa mining plan ngayon is only 22 meters. Although geologically wise, hindi pa nagbo-bottom yung deposit. So below that could still be a potential source of magnetite, economic quantity of magnetite. So limited lang yung data kasi. Yung drilling kasi hindi na pursue deeper. So up to 22 meters lang yung pinakamalalim.
Alright. So sir, siguro follow up lang to that. Is there a limitation into the, parang may max ba kayo dun sa allowed drilling? Kaya you limited it to 22 meters?
Of course, may limitation yung drilling in the past. But based dun sa previous consultant, that is enough to obtain a quantity that is targeted. Ang limitation naman sa actual mining would be the reach of the dredger. So kung ano yung reach ng dredger, yun ang magiging limitation. Our dredger can go down as 30 meters, I think at least 30 meters. Kaya.
All right, thank you for that, Sir Mon. Here's another question for you. What are your thoughts, actions on the massive protest, disapproval of the people of Cagayan on the proposed offshore mining on their coastline area?
I'm not surprised kasi marami naman talaga yung nag-oppose any development. More particularly mining. Mining is demonized. Just because it's called offshore mining, marami talagang mag-oppose dyan. Even if their concern scientifically may not be very sound. But we believe that una-una, we try to educate as much as we can dun sa talagang communities, yung mga tunay na stakeholders. So we focus our IEC there. We ensure that they understand exactly what is the plan of the company and the whole project itself. Hindi namin ma-address of course yung mga taong outside the impact areas na hindi namin alam kung taga-saan sila talaga. And yet they just oppose the project. Marami naman ganyan eh. Let's admit it. Na maraming dayuhan na nag-oppose. So in that case, we cannot do that. We have to use science as our basis. We are trying very hard and we are successful in being very, very transparent with the project. So sinasabi namin lahat talaga ano yung potential impact, ano yung potential benefits of the project. That's why a lot of the stakeholders in the municipality of Gonzaga at saka yung neighboring municipalities has issued approval to the project. That was a tedious, long process before they issued that. So hindi basta-basta may issue yung approval or endorsement.
All right, thank you for that clarification, Sir Mon. Here's a question for Engineer Ted, though I think it's also possible for you, Sir Mon, to answer this given your background. So what are the components of a coastal geohazard assessment relevant for offshore mining? At what stage in the mining process will the coastal geohazard assessment be conducted?
I think si Dr. Sharina ang
All right, go.
this. What I can say lang is our project site is at least 15 kilometers away. So if they can visualize that, kanina nga, just to help most of the audience visualize it, yung distance between Rizal Monument and Oblation, you can put it inside the area, and yet you're still short by 2 kilometers, 2 to 3 kilometers. So ganun kalayo.
Yeah, Dr. Rina, please go ahead if you have something to add to answer the question. Nakamute kayo, ma'am.
Pakiulit-uli, ano yung hindi nasagot na question?
So the question is, what are the mali. What are the components of a coastal geohazard assessment relevant for offshore mining? At what stage in the mining process will the coastal geohazard assessment be conducted?
I think that's guidelines and policies of MJB. So, hindi ko rin alam on basta before they approve the permit, they need to have like geohazard assessment and EIS na kailangan gawin. So, yun yung idea ko na before the mining operation will commence, then all of those EIS and geohazard assessment should be done na before the operation.
Okay, thank you, Dr. Rina. Here's a question for Sir Mon. Sir Mon, can you also shed light, provide explanation on the non-compliant status of JDVC? During the duration of my data gathering for my graduate thesis, MGB Region 2 said that JDVC is not compliant on the submission of your tenement, environmental, and social development programs.
I don't know where you got that data, but I respect you. Kung sino ka man nagawa ng yung study mo na yan, I respect you because you have your own source. But I cannot comment because study mo yan eh. So, hindi ko naman alam yung detalye ni study mo. Who are your sources and how credible are they? But one thing that I can share with you is just recently, I think I'm talking about the month of June this year. We were issued by the Regional Director of MGB Region 2 in Tuguegarao a certificate of good standing. So that means we are compliant with all the regulation, wala kaming violation. And that should speak for itself.
All right. Okay, here's a raised hand pala, no, Dr. Yolanda Aguilar. I'm sorry, I did not see the raised hand. So please go ahead and respond to this question or a previous question that was raised earlier.
You mentioned about the coastal and marine geohazard assessment of Cagayan. Actually, the MGB through the Marine Geological Survey Division is currently conducting coastal geohazard assessment around the Philippines. So what we do is like we do beach profiling and then echo sounder survey, like bathymetric survey. So we would like to know the sea floor topography of the area. In the case of JDVC, I advise that they from time to time conduct or monitor the changes in the topography of the continental shelf around their mine site, because they will be suctioning and getting sediments from the ocean. So there will be artificial, what do you call it? Bangin ba? Magkakaroon ng, yeah. So there's a possibility that, especially the coastal areas of Cagayan is mostly covered by loose sand. So there might be some collapse because the hard rocks are usually exposed north of Santa Ana. In the Apari area, it's more loose sand. The hard rocks are mostly north of Santa Ana and Claveria. So I think they have to monitor the sea morphology or the bathymetry of the mine site.
Ma'am, may I clarify some points that you have mentioned, no? So you're right now, you mentioned right now that JDVC has to do some regular monitoring of the change in bathymetry or topography. So parang is this incorporated in some guidelines that they have to follow, or kasi parang worried lang ako na ngayon lang pwede kasi ngayon lang siya na mention, and so therefore they might not be aware of this necessity, and so therefore parang we might have something to work on to ensure that they are aware of this necessity to monitor and of course maintain safety.
That is actually my personal opinion, because I've been to those areas before in the conduct of geological studies, and I found that most of those areas are underlain by loose sand. Unlike in other coastal areas wherein we have rocky shores or fringing reefs, but in the case of Cagayan, we rarely see coral communities. So weak yung yung coastal areas natin. And then if there will be some artificial cliff under the sea, there could be a possibility of collapse. It depends on the season. Like during amihan season, the area is exposed to big waves coming from the north.
So right now, ma'am, there's really no guidelines that requires them, or parang law that requires them to do some regular monitoring. Did I get your answer correctly?
Because actually, I'm also a member of the feasibility study committee of the MJB, but most of the applications that we are evaluating are for onshore mining. We rarely receive applicants for offshore mining. So yeah, in the case of Cagayan, which is underlain by loose sand, I think there's a need for monitoring of the change in topography of the seabed.
Okay. See, Mr. Joey Ison is also suggesting that they can check if it is covered by the EPEP of JVDC on regular monitoring of the bathymetry. So I'd also like to ask Dr. Charina, no, in the absence of that particular guidelines, no, parang even in the particular location of JDVC's offshore mining project, no, parang given the uniqueness that Dr. Yolanda mentioned, no, in terms of the kind of seabed that this area has, parang in your perspective, do you have any suggestions on how frequent should the monitoring be performed, or this requires some further modeling and therefore from there you can only determine how frequent should the monitoring be done? Ma'am, nakamute po ulit kayo.
Okay. Actually, they should go both together. So habang may hydrodynamic modeling, dapat meron talaga monitoring before, during, and after. So I think this is my personal view. It should be a requirement for the company to have regular monitoring, kasi significant yung magiging change kapag you're mining seabed under under the water kasi. So it will change your currents, it will change your tides. So bathymetry survey should be conducted depending on how intensive the dredging activity is. So kung masyadong intensive, then they can do a survey like every month to see the changes in the bathymetry and then see and input that, update that in your hydrodynamic modeling. With that change, anong mangyayari on your currents and in your sediment plume and sediment transport. So you need to update your modeling kapag may changes na nangyari dun sa seafloor at sa seabed.
Right. Sir Mon, would you like to add to any further comment to that?
Yes, I'm just waiting for my turn. As a miner, when you mine, you have to know where you are mining and how is your mining, yung extent ng mining mo is progressing. So we really have no choice but to monitor that. Kasi kailangan alam namin talaga yung source ng dredge material eh. Alam namin gaano kalalim, ano yung exact location ng dredge. So that is part of the data that we will derive from that mining monitoring is the monitoring na rin ng bathymetry. Kasi we have to know really the configuration of the seabed na minimina. So hindi pwedeng magmimina blindly. So for me as a mining engineer, that's given. We will have to do that. We will not mine blindly. Ngayon, also, let me add, yung seabed, not all of the materials would be taken out. The maximum, based on my computation, is only 20% of the material. Kasi yung grade nga nung average grade ng deposit, diba? 26%. And part of the 26% middlings pa. So sa estimate ko, only around 20% of the volume of the material would be extracted out in the form of magnetite concentrate. So the remaining 80% will have to be returned. So yung i-return na yon, ang pinaka net effect lang is only 20%. So kung i-spread mo yan over 1,897 hectares, yung 900,000 metric tons per year, if you will spread it out, it's only very thin. Pero of course, hindi naman ganun nangyayari. Of course, we mine on a certain area. Ang point lang is, don't worry. We have to monitor it because it would affect the mining operation. Secondly, 80% of the materials would be returned, so it would mitigate. It would be a good mitigation also. And of course, the marine environment, especially in the north, is a very dynamic environment. So yung current na yan somehow contributes to the dispersal of sediments sa area. So yun lang.
Okay.
Sir, may tanong ako kay sir.
Yes, please go ahead, Dr. Sharina.
Sir, yung monitoring data niyo po, kanino po sinasabit?
Kaya sasabit?
Oo.
Sa regional office 2, both MGB and EMB.
And it's also accessible for upon request
Oo.
for scientific study. Okay. So the region 2, sir, no?
ISO 1, sa yung ISO parang compliance, we have to prepare all the documents needed and comply with all the regulation, reportorial requirements. Otherwise, hindi kami ma-certify.
Yeah, so region 2 is holding this data. So doon kayo
Yes.
nagsasabi. Okay.
Kaya sila yung nag-issue sa amin ng Certificate of Good Standing. Kung hindi ako nagkakamali, first week of June, nag-issue si RD Mario Ancheta ng certificate sa amin.
Okay, sir. Noted. Thank you.
Okay, thank you. Thank you, Sir Mon, Dr. Rina, Doc Yolanda Aguilar, and for Sir Ted Dino na wala na sa ating activity, but nonetheless, we are so grateful. Siguro, to close this to close this Q&A session. Sir Mon, Dr. Rina, and Dr. Aguilar, there are still several questions in our Q&A box that if you can spare some time, if you have some quick answers to their questions, please provide them some notes or some points that they can carry from this webinar. And hopefully, if you can, we're willing to answer these questions also offline and send them directly through their emails. Please share to each other na lang po your email, your contact information, so that the discussion can continue. But what I can also say from this Q&A and webinar is that it is actually our desire from Triple M and SMEP that this occasion can also sort of become an opportunity to initiate some potential collaboration between the industry, the professional organizations, and the academe to address certain issues that will help us ensure that the mining operations in the country respond to the economic needs without really having to sacrifice badly the environment that we all so depend on. So with that po, we thank you for your time. Thank you for giving me this opportunity to moderate the whole Q&A forum po. So may I now return the floor to Doc Kate or to Christian Aranz?
Yes po. Thank you so much, Doc K. Doc Les pala, sorry. Ayan po. She is again one of the professors of our department, the UP Department of Mining, Metallurgical, and Materials Engineering, who has excellently moderated the Q&A open forum of this webinar. Thank you again also to our distinguished panel of speakers. Kahit po umalis na po si Doc Ted, si Engineer Ted, sorry. Nandito pa naman po si Engineer Mon and si Doc Charina and si Doc Yoli. So thank you po ulit. I could definitely say that we have learned a lot of things, so many things about this very timely and interesting topic. So ayan po, before we end, I would just like to call on our final speaker for this afternoon. We have our closing remarks to be delivered by Dr. Alberto Amorsolo. He is the president of the Society of Metallurgical Engineers of the Philippines and a professor here also in our department. Doc A. Ayan, nandito na po siya.
Yeah. Good afternoon to everyone. So actually, I prepared a summary of what was discussed in this forum. And so we had our offshore mining forum this afternoon, and this featured four distinguished speakers from industry, the government, Mines and Geosciences Bureau, and academia. And our first speaker was Engineer Teodorico Sandoval, and he talked about the Mines and Geosciences Bureau revised guidelines on offshore mining. And he actually mentioned the legal basis for offshore mining under Republic Act 7942 and also EO 153. And basically, when you do offshore mining, you should try to maintain the biodiversity of the marine environment, and of course, maintain the safety in marine navigation areas, and okay. And he mentioned also that in offshore mining, actually, no permanent structures will be no permanent structures will be built. So after the end of the mining, all these structures will be removed. And he also mentioned about the performance bond that the company has to give, so that in case some obligations are not met, then that will be source for the compensation for not meeting this obligation. And there we also learned that in offshore mining methods, there will be no use of high pressure water jets, and among the prohibited will be also the use of chemicals, and even site reduction processes are prohibited. So I suppose there will be no grinding possible sa offshore mining operation, and of course it should comply with environmental provisions and the international standards, and there should be control of the sedimentation, and the waste from the operations will be through submerged pipe discharge. Okay. The next speaker was Dr. Yolanda Aguilar from the Marine Geology Survey Division of the Bureau of Mines and Geosciences, and she talked about the offshore mineral resources in the Philippines. So actually, the Philippines is heavily mineralized, not just in its in the land part, but also in the marine part, and there are many potential minerals, both metallic and non-metallic, such as gold, chromite, of course, magnetite, silica, and manganese, and these are distributed all over the country. And he even mentioned occurrence of some rare earth minerals in some localities. So she also talked about the methodology for offshore mineral exploration. And okay, so overall, we got a good picture of the potential resources that can be tapped for these offshore mining activities if it comes into implementation stage. The third speaker was, of course, Engineer Ramon Santos, and he talked about the JDVC magnetite sand offshore mining project, okay, which will be implemented in Gonzaga, Cagayan. It has a projected lifetime of 25 years, and it's renewable for another 25 years. Roughly 15 kilometers, located 15 kilometers offshore, and the MPSA covers 1,897 hectares. He also talked about the feasibility of the exploration involved in this project, and so actually it's a long process. The survey started in 1969, and now they're getting ready to implement it, and it's already 2021. So it has to go the thorough process, the same as with land-based mining. And okay, so Engineer Santos also gave an estimate of the mineral resources. It will roughly produce about 900,000 metric tons is per year. And among the features of the operation is that the magnetite sand will be mined using siphon vessels. So this is suction dredging, which does not use a high pressure jet. And he also showed us the flow sheet, where basically the mineral processing part is simply the use of the trommel coupled with a magnetic separation with a roughing and cleaning stage. And the concentrate will be less than 10 mesh size. So the particles exceeding 10 mesh will be considered as waste and will be returned to the seafloor. Okay, so the grade that is targeted to be produced of the concentrate is over 60%, and it will be considered already as marketable. Okay, so the final speaker was Dr. Charina Lynn Meda from the Repolyo from the Marine Science Institute, and she talked about the potential impacts of offshore mining to our oceans. Okay, so there it was mentioned. So it was mentioned that the different types of offshore mining methods, and he mentioned laser mining using. She presented the table with and the dredging operations will typically involve depths from 30 meters using a cutter section dredger, and this is supposed to have a high production rate and moderate seaworthiness. Okay, and among the effects, possible effects mentioned will be changes in turbidity, the production of passive as well as active sediment plume, noise generated from the machinery, even the lights, and possible changes in the tide, far field changes in the tides and currents, among others. And of course, in most cases, there will be an effect of on the fauna located in that mine site. She also presented the table with the possible effect, the spatial scale, the temporal scale of the effect, and the confidence in the evidence, and also mentioned about or discussed environmental cases of offshore mining effects observed in Europe and Australia, among others. And so these effects would include the possible impacts on the fauna of that environment. There will be also possible risk of spills of hydrocarbons, and if chemicals are used, the possible discharge into the environment, also the production of underwater noise, blasting and vibrations. And she also mentioned about the impact on ecosystem processes. And very importantly, she also provided a listing of the possible mitigation measures to address these possible adverse effects, such as the use of silk curtains and other measures. And it was all she also showed the maps of the wind patterns, surface circulation of currents in the Philippines, the sea surface temperature, chlorophyll concentration, and also mentioned about internal waves signatures in the country, which will affect turbulence levels in the marine environment. And of course, he mentioned about the marine protected areas and showed us a map of where these are located. And if you look at the site for the Cagayan, it isn't located at that marine protected area. Okay. Yeah, so of course this was followed by the question and answer portion, and clarificatory answers were provided by the experts on the questions asked from the audience. And overall, this forum proved to be a very good exercise for an intelligent discussion on this topic, which has, well, I think what triggered this is some maybe articles in the media that would, voice out, let's say, views from the opposition side. And it's best to, before we can make good judgment on a certain issue, of course, there's a need to be well informed on all areas. So one should know all the raised pros and cons about a certain issue, so that we can come up with a sound opinion on that matter, which will be our guide to make decisions pertaining to, let's say, a project like this one. Okay, so SMEP has been trying to be involved in enlightening the non-MET and or those practitioners outside the mining industry on important issues related to the profession. And so we welcome the invitation from the UP Department of Mining, Metallurgical and Materials Engineering to co-sponsor this event, which I believe has been very successful, with active participation from a lot of participants from all interested sectors in our society. Okay, so with that, I end this closing remark part, and I would look forward to more activities of this type in the future. Okay, so by the way, SMEP will be holding our MetCon metallurgical conference sometime in around third week of October. And we hope again that especially the MET participants and even those in the allied fields, because it's going to be a virtual conference, will also actively participate in this future activity of this society. Okay, so thank you very much, and I hope you have a good week ahead.
Okay po. Thank you so much, Dr. Amor Solo. That was very comprehensive, all of your summaries and the closing remarks. So that would formally end the event. But ayan po, if you notice, you have been promoted to panelists. So may I request everyone to please turn on your camera so we can take a very big group picture of everyone here who stayed and who remained. So yan. Sige, habang ina-open niyo po yan, I would just like to acknowledge all of the participants, all of the speakers, our co-faculty here, si Doc Candy nandito pa. Thank you ulit kay Doc Les na nag-moderate. And also kay Doc Kate. Ayan, si Doc Kate. Thank you, Doc Kate, for anong tawag dito? Being at the back end of ayan, ang daming mga slight problems, pero ayan, nagawa naman ng paraan. So ayan, let's wait for other people to turn on their cameras, please, if you can, so we can take a group photo. Ayan po. Sige, nag-open pa yung iba.
Yeah, I would like to congratulate the UP Triple M at saka SMEP for this successful affair.
Thank you po, Sir Mon.
Thank you, Sir Mon.
Ayan.
Thank you very
sir.
much sa mga speakers. Very interesting and enlightening talaga ang na to.
Yeah. And also sa lahat po ng nag-participate, thank you very much.
Yeah, yung mga
Special those who
nyo,
stayed.
yung mga engineers natin na nandito. I hope marami kayong natutunan.
Yes. Yung mga students po pala, ayan, students namin, hi. And also, thank you kay Ma'am Hana, kay Miss Neri, yan yung mga nasa back-end ng webinar.
Yeah.
Ayan.
Yan.
So,
mga sa background, si Neri, si Hana, si Joy.
Ayan si Ma'am Joy pa pala. Ayan, thank you po.
And
Ayan,
thank you
I
so
think
much to Doc
naka-open na
Les
po.
sa pag-moderate. Thank you so much, man, for keeping the time.
Ayan. I think we
Thank you
can all
for
smile.
inviting me.
Ayaw
Ayan,
pumasok
Mon.
nung ibang
Ay, sorry.
ibang
Sige po.
pinomote ko. Sorry. So, anyways.
Meron pa po ba? Meron pa po di nakakapasok?
Nagre-request sa chat, pakiulit daw. Kasi nagkamali daw siyang pindot.
Okay. Okay. Wait lang, ma'am.
Sige po.
Sige, ito po. Ayan. Inuulit ko na po lahat. Ayan.
Meron pa po palang nasa hindi pa napopromote to panelist. Wait lang. Tapos sila po para makapasok po sila.
Oo. Okay.
Apat.
Isa-isa pala to. Walang
Opo,
promote all.
isa-isa po. Wala pong mass promotion.
Walang mass promotion.
Opo. Anyway, sige po, mag-standby lang po kayo. Sorry po, a few more seconds. On lang po yung camera, and then I'll take a picture po in a while. Tapos, ayan, mag-ayos-ayos na po yung mga...
Ludwig, Ludwig, magpakita ka.
Ayan. So anyways, mukhang hindi na po yata
papasok yung iba.
Anyway, sige po. Ayan po, I'll count down po in 3, 2, 1, smile.
Yes.
Ayan. Next batch po, 3 pages po siya ng mga tao. 3, 2, 1. Okay, another po. Again, in 3, 2, 1, smile. Ayan. So, ayan po. Maraming salamat po sa lahat ng umattend. Thank you. Have a nice weekend.
And thank you din sa mga alumni ng department. Ay, naka-raisan pa si Dr. Yolanda. Sa alumni po ng department, hello.
Sama ako doon.
Yes po.
Kaya po si Sir Mon. Thank you. Thank you po sa lahat ng umattend.
Thank you. Maraming
Thank you
salamat.
po.
Thank you for the opportunity.
Thank you po.
Thank you po.
Salamat po.
Bye.
Hanggang sa ulitin po.
Yes.
Salamat po. Sino po ang mag-e-end? Doc Kate, kayo po ata ang
Hindi, ikaw ata.
Ay, ako
Ikaw,
ba?
Rara.
Ako pala. Sige po.
Ikaw,
i-end ko
Rara.
na po.
Thank
Bye-bye
you.
po.
Thank you po.
Okay, bye-bye.
Thank you.
Thank you.